Hello and welcome, fellow code cultists, to our Python for Beginners tutorial series. I'm Tom Mikkel, and I'm excited to guide you on your journey into the world of programming with Python. Whether you're an aspiring developer, a curious tech enthusiast, or just someone looking to pick up a new skill, you're in the right place. Python is a powerful and versatile programming language known for its simplicity and readability. Throughout this course, we'll be delving into the fundamental concepts of Python, step by step, to ensure you build a strong foundation. By the end of this series, you'll be equipped with the knowledge to start creating your own Python programs and even some exciting projects. Here's a quick overview of what we'll be covering. 1. Installation. We'll kick things off by installing Python on your machine, making sure you're all set to start coding. 2. Basic commands. We'll explore the basic building blocks of Python syntax, from printing hello, world, to understanding variables and data types. 3. Intro to Jupyter Notebook. I'll introduce you to the fantastic world of Jupyter Notebook, an interactive environment perfect for experimenting with code and data. 4th, Basics of Jupyter Notebook. We'll dive deeper into Jupyter Notebook, covering its features and how to create neat and organized code cells. 5. Numbers and arithmetic. Learn how to work with numbers, perform arithmetic operations, and manipulate numerical data effectively. 6. Decimals. Discover the importance of decimal precision in programming and how Python handles decimal numbers. 7. Lists. Explore one of Python's most versatile data structures for holding collections of items. 8. Dictionaries. Understand dictionaries, a key-value data structure that's incredibly useful for organizing and retrieving data. 9. Tuples. Dive into immutable sequences of data with tuples and learn when and how to use them. 10. Sets. Explore the world of sets, unordered collections of unique elements, and grasp their significance. But that's not all. Along the way, we'll also work on some hands-on Python projects that will put your newfound knowledge into practice. These projects will not only reinforce what you've learned but also give you a taste of real-world coding scenarios. So, if you're ready to embark on this coding journey and become part of our growing code cult community, don't forget to hit that subscribe button and ring the notification bell so you won't miss any of our upcoming tutorials. Get ready to unlock the world of programming with Python. Let's dive into the video.
Now, learning Python would be no fun if you were to simply watch and observe what I do throughout this course. That's why we're going to get you set up with Python, as well as install a text editor that will allow you to write your code so that you can code along with me and experience the benefits of Python firsthand. It's only when you get stuck in and immerse yourself in the coding world when you will really start to understand how it works and how it can be used to its full potential. If you have Python 3 installed as well as a text editor, feel free to move on to the next video. If you haven't, continue watching and we'll have you set up in a few minutes. Now, whenever I get a new laptop or a PC and want to install Python, I usually opt for the same installation option every time, and this is Anaconda. This will not only install Python on your machine, but it will also come pre-installed with very useful packages that you will no doubt use in your coding journey. So rather than downloading Python and then installing common packages separately, you can install Anaconda, which comes pre-shipped with some very useful stuff. One of these things being Jupyter Notebook, which we will be predominantly using in this course to learn the Python language. So if this route sounds right for you, then all you need to do is type www.anaconda.com into a web browser, and this will take you to the Anaconda homepage. Right in the middle, you will see the ability to download Anaconda for Windows. So if you are operating a Windows machine, click the green button. Otherwise, you can select the little apple icon for Mac downloads or the penguin icon for Linux downloads. Seeing as I'm using a Windows machine, I will simply click on the green button. And when I do this, the Anaconda graphical installer will start downloading instantly. If you've selected Mac, just download the 64-bit graphical installer, or if you've selected Linux, download the 64-bit installer for Linux, and your download will start respectively. Now this will take some time to run, so take yourself off, make a coffee or tea, and it should be done when you're back. Rather than you sitting and waiting for this to download on my side, I will fast forward this part to save time. Now once done, open the file that was downloaded and you'll be presented with the Anaconda setup wizard like so. Now just like most installations, you can hit next to continue and you need to agree to the license agreement. So give this a read if you wish, but in short, to use this distribution, you need to agree to it. Next, you can select Just Me for the installation type and then hit next. You will then be asked to choose an installation location. Now I'm happy with the default destination folder that is appearing here in my C drive and users, then Tom, but if you would like to change your location, then you have the ability to browse and select your location accordingly. You will then be presented with some advanced options, but for this I would recommend selecting Register Anaconda 3 as my default Python 3.9 and then simply hit Install. When you do this, it will take a few minutes to perform the installation. Now once the installation has complete, you can hit next and then you are presented with some helpful tips and resources to get you started. But at this point, you are done. So you can click finish and you will now have Python installed on your machine. It's that easy. Now not only will you have Python installed on your machine, but you will also have what is known as Jupyter Notebook, which we'll introduce more in a minute, but let's open this up to see that it's installed everything correctly. So in your search bar, type Anaconda, and this will bring up the Anaconda prompt, which is what you're trying to find. Select this, and you are now inside Jupyter. Welcome. To start a new notebook, click on New on the right-hand side here, and then select Python 3, and you'll be taken to a blank Jupyter notebook where we can now write code. Now, if Python was installed correctly, we should be able to write some code and for the code to then be interpreted and run correctly. So to prove this, I can quickly type A equals 1, then I can put B equals 2, and then I can press Shift Enter to run this code cell. When I now type A plus B and then press Shift and Enter, we get 3 returned to the screen, which tells me we are set up correctly. Don't worry about what this code represents for now and what we've just typed our code into. This will all be explained in upcoming videos. As of now, this just tells us we are set up and ready to go. Now there will be times when you want to write your code outside of Jupyter Notebook. And in this course, we do have projects in which we code outside of Jupyter Notebook. So the next thing you'll need is a text editor or an integrated development environment in which you can write some code. Now my personal favorite at the moment is Visual Studio Code, but there are many other options such as PyCharm, Sublime Text, Atom, Notepad++, and a whole lot more. Now the debate over which is the best is forever ongoing, but you should come to find one you enjoy using and just go with that. At the end of the day, it's used to write code and they more or less achieve the same thing, albeit with some plugins that can make the experience of writing and creating code files a little easier. Now downloading an integrated development environment is no harder than Googling your IDE of choice. So let's for example say we want to download Visual Studio Code. So if I type Visual Studio Code into a web browser, here we are then presented with the Visual Studio Code's website. And I can see here we have a download option. So if I click this, I can then select my operating system. In my case it's a Windows machine, but choose yours respectively. When I do this, Visual Studio Code user setup starts downloading. And when it's complete, I'm able to open the file. When I do this, in a very similar way to Anaconda, I get a license agreement for which I need to accept. So I can click on accept and then next. I can then select the destination of the installation, so I'll leave this as the default path that appears in this window. I can then click next. I can then select a start menu folder, so I'll just click next on this menu. I can then choose some additional tasks, but I'll leave it selecting register code as an editor for supported file types, as well as adding Visual Studio Code to path. I can then hit next. This will then install Visual Studio Code, and once it's complete, Visual Studio Code will then automatically open. You are now set up with the ability to write code in files within Visual Studio Code. So if I create a new text file and select Python as my language of choice, I can now start typing code, and then we can save the file and run it accordingly. But more on this later. For now, you are set up with Python, you are set up with Jupyter Notebook, and you are set up with an integrated development environment if you've chosen Visual Studio Code. So if you have managed to get all of the above installed, you should have everything you need to start coding along with me and learning the wonderful language of Python. If you have run into any issues with the installation, please feel free to reach out to me in a personal message, and we'll try to address your issue and get you set up as quickly as possible. With the installation out of the way, next up we'll take a look at some command line basics. Now you will also hear the command line referred to as the CLI or command line interface. Sometimes you'll hear the console, the terminal, or the shell, depending on who you speak to and what operating system you are working on. Now they all have slightly different meanings, but we won't get bogged down in this detail for now. For now, we can think of these terms as being a way of a person, like you and me, interacting and communicating to our computer, whether you're working on a Windows PC, a Mac operating system, or Linux. Now the command line is one of the most useful and efficient tools we have as developers, but it is often overlooked as it can sometimes feel a bit complicated when you're starting out. But to put things into context straight away, let's suppose I ask you to navigate to your pictures folder on your computer. How would you go about doing this? Well, if I were to have a guess, you would probably do something like this. You would open up the File Explorer on your computer, and then you'd click on the respective folders until you get to the Pictures directory. So in my case, I can click on this PC, and then I can click on the Pictures folder, which takes me to the folder I wanted to get to. But one thing you may not have thought about is the following. Most operating systems have two different types of interfaces that users can interact with. The first is the graphical user interface, or GUI for short, and this is where a user can see things on the screen, click on them, and the computer will respond to those events by executing the corresponding task. Exactly the method of navigation we've just seen. The second is the command line interface, or CLI for short, which takes commands as inputs in order for the computer to execute tasks. So if I just take a look at the Pictures folder's properties, you can see here under Location that the Pictures folder resides within the C drive, then a folder called Users, then Tom, then Pictures. Now in this folder we have two further folders, one labelled Camera Roll and one labelled Saved Pictures. So let's now observe some basic command line syntax to enable us to programmatically move through the computer's directories and get to the folder locations that we're searching for. Now during the course, we'll be using something called Jupyter Notebook extensively. Not only is it where we'll be writing our code and learning the ins and outs of Python, but it's also where we will see and observe the output of our code to ascertain whether it's working correctly or not. If you are already familiar with Jupyter Notebook and want to skip ahead to the main content, feel free to do so. This video is for those who want to install and learn how to use Jupyter, as well as pick up a few shortcut tips when working in a notebook. So what is Jupyter Notebook? Well, Jupyter Notebook is an open source web application that can be used to create documents that contain live code. But not only can you write code in notebooks, you can also include equations, visualizations to observe your output, and narrative text, which can help explain to users what each section of your notebook is doing. Now once you've created a notebook, sharing it with your intended audience is easy, and I'll show you how you can do this. Now a little interesting fact for you is that the name Jupyter comes from the main languages that it supports, and these being Julia, Python, and R. Now Jupyter comes with what is known as the IPython kernel, which allows you to write your programs in Python. But there are actually over 100 other kernels that you can also use. So if you're keen on learning other programming languages, utilizing a Jupyter notebook would be a great place to do so. So with respect to installation, well firstly, if you've previously installed Python from their website, Jupyter Notebook is not included. So if you want to use it, you'll need to install it. And to install it, providing you are using Python 3, you can use a handy tool that comes with Python called pip. So in your command line, you can write something like pip install Jupyter, and then Jupyter will be installed. Now for me personally, whenever I install Python on a machine, I use the Anaconda distribution. And why do I do this? Well, Anaconda comes with many pre-installed libraries that are commonly used in data science, and this includes Jupyter Notebook. So you don't actually need to do anything other than install Anaconda itself. Very simple. Okay, so if you followed along with my installation of Python utilizing Anaconda, we're ready to dive in. And you will see a URL which looks something like this: localhost:8888/tree. And your browser should now have a list of files that look familiar. In fact, it will be the same structure as the folder you selected in your command prompt, which in my case was the Python folder. So it has all of these files in it. Now at this point, you're not actually running a notebook, you're just running the notebook server. So to create a notebook, all you need to do is click on the new button here, and it will open up a list of choices. Now on my machine, I only have Python 3 installed, so I can click on Python 3. If you had multiple kernels for other languages, you could select on one of these. But seeing as we're learning Python, Python 3 is exactly what we need. You will then be presented with a notebook that looks something like this. And you're going to become very familiar with this type of view because 90% of the course will use Jupyter Notebook. Now the first thing that may grab your attention is the name of the file. Currently at the top you can see that it says Untitled. Now this is the title for the page and it's the name of your notebook. Untitled isn't a great name, so let's change it. Just move your mouse over the word Untitled and click on the text. You should then see an in-browser pop-up which says Rename Notebook. So we can type something like Jupyter Notebook Overview. When I click Rename, you can see our notebook is now set up and it's titled accordingly. So we're now at the point where we can start writing code into the notebook, and there are many hints and tips that I'm going to share with you in the next video that will make your experience working with Jupyter as smooth as possible. Okay, so continuing from where we left off, we have a blank Jupyter notebook in which we can start writing code. And you'll notice that when we first go into a notebook, we get one empty cell that has this green box around it. We also have a flashing cursor, and also notice here that we have a little pencil symbol. What this means is that you're in an active cell, and this cell is ready to consume code. So just to verify that everything is working as it should, let's now add some Python code to this cell and then run its contents. So if I simply put print and put the string hello, and don't worry about this for now, we do cover everything in detail in the next section, we have now written some code in an active cell, but we haven't yet run the cell. Running a cell means that we execute the cell's contents, and to execute a cell, I can simply click on the run button within this toolbar and the cell will run. You can see that once I've clicked run, the cell is executed, a new code cell appears underneath in which we can write code, and our first line of code has the number 1 inside of square brackets. Now what this means is that this cell has completed running and it was the first cell that we run. If I now write another line of code in the cell underneath, and write print goodbye, you can see that the second cell has now run. It has the number 2 inside because it's the second cell that was run in this notebook. And we've got another cell underneath in which we can start writing. Now you will have multiple cells in your notebook, and you would normally run the cells in order. But if I press the up arrow twice and go back to the very first code cell, and then run this cell again, you can now see that we have a 3 inside of the top cell, a 2 in the second cell, because the top cell is now the latest code cell to be run. Now if you didn't want to click on the run button, there are some shortcuts you can use to run code cells. You can simply press Ctrl and Enter, which will run the code cell and keep the code cell selected after it has been run. You can also press Shift and Enter when you're on a code cell, which will actually run the cell and then select the cell below. Or you can also press Alt and Enter, or on a Mac this will be Option and Enter, and this will run the cell and insert a new code cell below. So you have a few options here with respect to executing and running a specific code cell. Now we've seen that when you have a code cell selected, a green box appears around the outside, which means that you're in an active cell. Now if I press Escape, you will see that the code cell has a blue bar down the left hand side and the pencil symbol disappears. This essentially means I'm in command mode and I can now use the up and down arrows to navigate the code cells accordingly. Now when you're in command mode, there are 2 very useful keyboard shortcuts that I want to share. Let's suppose I want to put a piece of code in between the print hello statement and the print goodbye statement. If I have the very top cell selected, i.e. print hello, I can put a cell underneath this cell by pressing the B key on the keyboard. Now this needs to be done when I'm in command mode, i.e. when I have that blue bar on the left hand side. And the B essentially stands for below. Alternatively, if I go down to the print goodbye statement and then press the letter A on the keyboard, this will place a cell above the cell that you had selected. So B places a new code cell below, A places a new code cell above. If I want to delete a code cell, I can double tap the letter D on the keyboard and this will delete a cell in its entirety. Once again, this needs to be done when you're in the command mode, which is done by pressing the escape key. So 3 very common keyboard shortcuts that you'll no doubt use frequently. Now so far, we've been working within a cell type known as a code cell. And this can be seen within this drop-down menu here. It states code. And this means that we can write code in these cells, and when we execute them, they will be interpreted and run accordingly. But we also have a couple of other code cell types. In fact, there are 4 cell types that we can use. We can use code, markdown, raw NB convert, and heading. Now the heading cell type is actually no longer supported and will show you a message that states that. Now instead, you're supposed to use markdown for your headings. And the raw NB convert cell type is really only intended for special use cases, so we're not going to touch on this for now. So the other cell type that I want to introduce you to is the markdown cell type. Now we've already seen how the code cell works, so let's now learn how to style text by using the markdown cell type. So if I select a new code cell, by default we work with a code cell type, but to change this I can either select this drop down menu here, or when in command mode I can press the M on the keyboard. M stands for markdown. Now when I do this, you can see that the in and the square brackets on the left hand side of the cell disappears. This now means we're working within a markdown cell, and if I press return, we then can activate that cell, which then shows that green box and the pencil up here. I can then write some narrative text which helps supplement the notebook with additional information. For example, I could put, "This is some text." Now to execute this code cell, we run the exact same shortcuts as we learned previously, and you can then see that "this is some text" is displayed to the screen. Now Markdown is a markup language that is a superset of HTML. So if I now go back up to that Markdown cell and put an asterisk symbol before and after the word text, this will change the word text into italics. So we're even able to change the style of the markdown that we write. And if you're familiar with HTML, we can utilize HTML tags. So if I wanted to convert the word text into a bold format, I can wrap this in a B tag like so. And if I also wanted to underline the now bold italic text, I can also wrap this in a U tag, which then underlines the text accordingly. Now, Jupyter allows us to create headers in Markdown, which are very useful to segregate your notebook into neatly organized sections. All we have to do is ensure we are in a Markdown cell and then type the hash symbol with a space. So for example, if I put the hash symbol and then write header 1, you can see that we get a big bold header when we run the cell. Now, the more hash symbols you use, the smaller the header becomes. So underneath header 1, if I were to write 2 hash symbols and then put header 2, and then underneath header 2 put 3 hash symbols and then header 3, you can even see a preview within the Markdown cell that hasn't been executed yet. But when I do execute this cell, you can see we end up with a nicely formatted header. Another thing you can do is create lists of bullet points, and you can do this by using dashes, plus signs, or asterisks. So for example, if I were to put an asterisk with a space and then put item 1, on the next line put a dash and a space, then put item 2, on the third line put a plus symbol and a space, and then put item 3, you can see that when I run this code cell, we get a list of 3 bullet points accordingly. Now we can also have sub items, so if I were to press the tab button and then put an asterisk and put sub item 1, you can see that we get a sub item accordingly with a different bullet point symbol. Now another great thing to note about Jupyter Notebook's Markdown capabilities is its syntax highlighting. Now if you want to insert a code example that you don't actually want your end users to run, i.e. you don't want it to be within a code cell, you can use Markdown to insert it. And the way we do this is by using inline code highlighting. To do this, all we need to do is surround the code with backticks. And all we need to use is triple backticks and then specify the programming language. So if I were to put to calculate 1 plus 1 in Python, all you need to do is, and then put a colon. On a new line, I can then put 3 backticks. I can then put the programming language Python. On a new line, I can then put the code that would need to be written in order to perform this calculation. So I could put print and then in brackets 1 plus 1. Underneath this, I can close the 3 backticks. And then when I run this code cell, you can see that we print the sentence accordingly, and then we get syntax highlighting with the exact code that would need to be written to print 1 plus 1 to the screen. A great way of being able to include syntax highlighting without your users having to run the actual code. Now within the menu bar, there are many standard options that you'll be familiar with, having used many other pieces of software I'm sure. So you can create a new notebook, you can open the notebook, you can rename it. One thing to highlight is the ability to download as. So this enables you to export the notebook that you're currently working in, and you have a list of different formats that you can convert your notebook into. So you've got .py, you can convert it into an HTML file, and so on. You have the edit menu, which enables you to cut cells, copy cells, undo, delete cells, etc. So explore these in your own time. In the view menu, you can toggle the header on and off, and you can toggle the toolbar on and off, which will provide you more space, but obviously you'll need to know some shortcuts if you do decide to toggle these off. We've seen how to insert cells above and below using the A and B letters on the keyboard. You can run cells using the cell menu. And one final thing to note here is that sometimes you may need to restart your kernel if, for example, you run into code that doesn't stop running. And this can happen, and we'll see this later in the course. So what this may mean is you need to come into kernel and then press on interrupt or restart in order to bring your notebook back to life. You can also restart and clear output, which will basically undo all the execution of your code cells, so you're back to square one. If you then want all of your code cells to run once your kernel has restarted, simply click on kernel and then restart and run all. So there you have it, Jupyter Notebook in a nutshell. Just like any application or program, you will become more comfortable using it the more you use it. Throughout the course, I will continue to showcase shortcuts and capabilities that Jupyter Notebook has to offer. But for now, this gives us the fundamental knowledge we need to get started with our Python learning. It's also worth noting that there are many cheat sheets available online. Just simply type Jupyter Notebook cheat sheet into Google and you'll be presented with many PDF files that contain the main shortcuts you need to operate efficiently in Jupyter. In the next section, we're going to focus on the most fundamental concepts in Python that will help tremendously in the subsequent sections. And these are things that you need to know before we dive into the more detailed aspects later on in the course. Numbers in Python. In fact, there are different numeric data types that a value can be. For example, we could have a number which is an integer, which are whole numbers without decimal figures. And for these types of values, we use the int keyword. So an integer could be used to store the number of steps you make in a day, for example. So I could type daily underscore steps equals 10,000. And then we could type an end of line comment saying hash this variable is storing an integer. And just to prove that this variable is indeed storing an integer value, we can use the built-in Python function called type to see what object we are working with. So we can write type and then put a set of brackets, also known as parentheses, just like we saw when we called upon the print function earlier in the course. Inside the parentheses, we can put the variable name, so daily underscore steps in this example, and we can place this inside the type function. When we run this, it brings back a result telling us that this is an int object, i.e. an integer. Now there may come a time when you want to use a number containing decimals. This can be achieved by using what is known as a floating point number, and we use the keyword float to denote this. So if I were to create a variable called film underscore rating and assign this the value 7.5, we are now storing what is known as a float inside the variable named film underscore rating. And if we check to see what the type of object stored inside the variable is, we get back the type float, just as expected. Now within the formal Python documentation, there is a section which references issues and limitations of using floating point numbers in arithmetic, and I've attached the relevant documentation in the resources section for you to take a look at in your own time if you're feeling inquisitive, but we won't go into any detail on this topic as of now. Now hopefully it is unsurprising when I say that Python can perform calculations and performs them extremely well. In fact, we saw a little example in the variables video when we created a variable called times_3 and stored the value 10 times 3. We can perform calculations in Python as if we were using a scientific calculator. For example, we can use the plus symbol for addition, so 2 plus 2 gives us 4. We can use the hyphen for subtraction, so 5 minus 3 gives us 2. We can use the asterisk or star syntax for multiplication, so 12 multiplied by 6 gives us 72. And we can also use the / for division, so 20 divided by 4 gives us 5. Now notice that when we use the division operator, the result is translated into a floating point number, i.e. a float. This is because Python converts all integers, i.e. whole numbers, to floats before performing a division calculation. Now when dividing in Python, you may also sometimes run into what is known as the zero division error. Now this occurs when you try to divide a number by 0. So as an example, if I type 10 divided by 0, you can see the error accordingly. So keep this in mind if you ever come across this issue. Now remembering what our maths teachers taught us at school, mathematical operations have an order in which they are performed, and Python is no different. Fortunately for us, Python follows the same standard mathematical order of operations. So if I were to type out 5 plus 2 multiplied by 5, we get 15 as the result, as Python first calculates the multiplication followed by the addition. To change the calculation to address the addition first, we can use brackets like so. And we then get 35 as the result when we run the code. Now when we assign values to variables, we've seen we can use these variables in other places in our code. Now we can use these variables in calculations as if they were the original literal value. So if we had a variable called sales which stored a value of 1000, a variable called cost which stored the value of 465, and then had a variable called profit which stored sales minus cost, i.e. we're using the variable names. If we print out the values stored in the profit variable, we get 535 returned. Now performing a calculation does not change the original value of the variable. So if I were to print out the value stored in sales, you can see that we still have the value of 1000 stored inside of it. Now if I were to update the value stored in the sales variable to say 1300 and rerun the code, you can see we now get a different profit figure as the value stored in sales was updated, and as the profit calculation references the sales number, we get an updated result. And if I run the print sales line of code, we get the updated value of 1300. So things to remember from this video. Numbers can be whole numbers, which are known as integers, or numbers can contain decimal figures, which are known as floating point numbers. You can assign them to variables, and you can then include the variables in calculations. Calculations follow the standard mathematical order of operations, and you can use addition, subtraction, multiplication, and division as you would on a standard calculator. Okay, so we've now explored integers and floating point numbers. We've stored them in variables, and we've performed some calculations. Now let's take a look at a few more number considerations. Firstly, Python offers a shorthand for updating variables. When you have a number saved in a variable and want to add a number to the current value of the variable, you can use the plus equals operator, which is simply done by putting a plus symbol followed by the equal symbol. So let's say we had a variable called footsteps, which stored the number 500 in it. We then go out for a walk and do another 2000 steps. We can now update the value stored in the footsteps variable by putting the name of the variable, and then plus equals, and then 2000. This will add 2000 to the value already stored in the variable footsteps. When I now print out footsteps, we get 2500 returned. Now we can take this further by adding other arithmetic operators followed by the equal sign. So we currently have 2500 in our variable called footsteps. But let's suppose we miscalculated and we want to deduct 300 from this value. Well, we can do this in two ways. We could firstly perform the calculation, footsteps minus 300, and then reassign the result of this to footsteps, which will override the original value. But despite this getting the right answer, we've had to write out the variable name footsteps twice. So not very efficient. A shortcut to achieve the same result is by putting our variable name that we want to change, in this case it's footsteps, and then putting a minus symbol followed by the equal symbol. When we now print out the result of footsteps, we get 2200 as the result. We can also use the multiply equals. So if we wanted to see how many steps we would do after a week of walking 2200 steps a day, we can put footsteps, which we know currently holds 2200, and then put star equals and then 7. This will change the value stored in the footsteps variable by multiplying the previous value by 7. So we get 15,400 when we look at the value stored in footsteps. And finally, if we wanted to divide the number stored in footsteps by 2, we can use the divide equals operator, and we update the variable value accordingly. So a nice clean way of being able to take a variable value and updating it for simple arithmetic operators. Now there are 3 more operators I want to share with you which come in handy for specific use cases. First up, floor division. Now the arithmetic operator for floor division, or integer division as it's sometimes called, rounds the result down to the nearest whole number. So let's take a simple calculation. 16 divided by 3. When we perform standard division, we get 5.333 recurring, which tells us that 3 goes into 16 5 times, and then we have 1 left over. Now the floor division operator is represented by two division signs, or two forward slashes. So writing 16//3 will give us 5 as the result, as it's rounding down the result to the nearest whole integer. In other words, just truncating the values after the decimal point. So 69 divided by 12 will give us 5.75, and therefore 69//12 gives us 5 as the result, as it's rounding down to the nearest integer. Secondly, and what is essentially the opposite of the floor division operator, is what is known as the modulus operator. Now in Python, and generally speaking, the modulo or modulus operator refers to the remainder from the division of the first argument to the second. And the modulus operator is done by using the percent symbol. So let's take a simple example. If we perform 16%3, we know that 3 goes into 16 5 times, and we are left with a remainder of 1. Therefore, when we run 16%3, we get 1 as the result. What do you think the answer to 69 modulo 12 will be? Take a moment to think of the answer in your head. When I run the code, I get 9 as the result. This is because 12 goes into 69 5 times, which takes us to 60, and we have 9 as a remainder to take us to 69. Now thirdly, you can also perform exponential calculations by using the double star syntax. So if you wanted to perform 8 to the power of 3, you can put 8 star star 3. And this will bring back the result of 8 multiplied by 8 multiplied by 8, which is 512. So 3 more arithmetic operators for you to digest and store in your calculation toolbox for when they are required. Okay, next up, let's take a brief look at the concept of type conversion. We can convert one type of number into another, and this is also known as coercion. Now look what happens when I carry out the calculation 1, which is an integer, plus 1.0. You can see we get back 2.0, despite the result having 0 decimal places. This is because operations like addition and subtraction coerce integers to floating point numbers automatically if one of the operands, i.e. numbers, is a float. Now we can also change the type of numbers ourselves by using built-in functions like int and float to convert between the types explicitly. So we can turn a floating point number into an integer by placing the floating point number inside the built-in int function. So 2.8 becomes 2 because the 0.8 is chopped off, i.e. it's truncated. We can also turn ints into floats by using the float built-in function. So float 10 will bring us back 10.0. So changing the type of a number can be done explicitly by using the built-in functions int and float and placing the value in the function's parentheses. Or depending on the calculation you are trying to perform, Python may automatically convert from an integer to a float or vice versa, depending on the operation. Okay, great, so we've covered a lot in this video. Just to summarize, you can use the plus equals operator or the same technique with other arithmetic operators to update variable values cleanly. You also have the floor division, which rounds down to the nearest whole number and is represented by a double division sign, so 2 forward slashes. You have the modulo operator, which obtains the remainder of a division and is represented by the percent symbol. And you can perform exponential calculations by using the double star syntax. Numbers can be converted between types, in other words they can go from one type, i.e. an integer, to another type, i.e. a floating point number. This is either done automatically by Python or can be explicitly defined in your code by using the built-in Python functions such as int or float. Right, so remember when I said Python was good at calculations? Well, let me give it a tough calculation to perform to see how it gets on. So Python, 1 plus 1 is the same as 2, correct? Okay, good, I'm glad this said true. How about 1.1 plus 1? Does this equal 2.1? Okay, yes, also true, good stuff. Now, does 1.1 plus 2.2 equal 3.3? False. Okay, I'm pretty sure Python is making a mistake here, so what's going on? Well, it turns out that floating point numbers are implemented in computer hardware as binary fractions, as the computer only understands zeros and ones. And it turns out that the decimal fraction 0.1 will result in an infinitely long binary fraction that looks something like this. And our computer will only store a finite number of it. Now this will only approximate therefore to 0.1, but will never be equal. Hence it's the limitation of our computer hardware and not an error in Python. So if I actually perform the calculation 1.1 plus 2.2, you can see we get 3.3 with a bunch of zeros and then 3 on the end. Now, due to this reason, most of the decimal fractions that we know cannot be accurately stored in our computer. So as an example, we cannot represent the fraction 1 over 3 as a decimal number. This will give us 0.333 recurring, which we know is infinitely long, and we can only approximate it. Now, to overcome this approximation issue, we can use the decimal module that comes with Python, which helps us work with high levels of precision. So while floating point numbers will enable us to have precision up to 15 decimal places, the decimal module allows the user to set the precision. So let's see how this can benefit us. Now for this part of the video, feel free to sit back and just observe what's happening. When it comes to importing modules and packages and how we can access different functions from this will be covered in detail later in the course. I just want you to see how the decimal module can help. So if we first of all import the decimal module, which now means we can utilize its functionality, I will first of all print 0.1 to the screen. I will then print 0.1, but I will access some functionality from the decimal module called decimal, in which I will pass in 0.1. Now when I run this code cell, you can see that we print 0.1, and then we print 0.1 with lots of zeros, and then 555, 111, and so on. So the decimal module is used when we want to carry out decimal calculations to a high precision, based on the value that's stored on our computer. Now if I were to ask you what's more accurate, 10.5 or 10.50, hopefully you'd tell me it's 10.50 because it has 2 significant decimal places compared to the one of 10.5. So working with more decimal places gives us higher precision. Now if I just import that same decimal function, but this time alias it as the letter D, which will just make the subsequent code more simple to type, if I now perform the calculation of 1.1 plus 2.2 and compare this to 3.3, this time passing it into that decimal function that comes from the decimal module, you can now see that we return true because we're working with a high precision of decimal figures that's stored on our machine. So you now may be thinking, well, if this is more accurate, why don't we just use the decimal module every time instead of using floats? Well, the main reason is efficiency. Now, floating point operations are carried out so much faster than decimal operations, and precision up to 15 decimal places is usually good enough for the granularity that we need. So when should we use the decimal module instead of floats? Well, we generally use decimal when we need high levels of precision. So for example, if we're making a financial application that needs exact decimal representation, then the decimal module would be a good option. We would also use the decimal module if we want to control the level of precision that's required. Now hopefully this highlights the nuance when working with floating point numbers and provides some clarity on how we can be more accurate with numbers when using Python. we have to be mindful that storing infinite numbers on a computer is not possible in finite memory. So the computer may perform some strange things if you're not aware of this nuance. If granularity and precision is what you need, the decimal module can certainly help you with this. Now, the final part I want to briefly touch on with respect to numbers in Python is the offering of modules that enable you to use numbers without having to remember them yourself. So for example, there is a module called Math that enables you to carry out different kinds of mathematics like trigonometry, probability, statistics, and so on. So let's say we want to reference the number for pi. We may remember our teachers telling us that pi is equal to 3.142. And some would show off by remembering even more decimal places. But with the math module, rather than having to type it in ourselves, we can use methods and attributes from the math module. So we can type import math, which is us telling Python to import a package that can perform certain tasks. This will be explained in a lot more detail when we discuss modules and packages later in the course. We can then type math, which is the name of the library, and then put a dot. This dot is just us telling Python that we want to perform some operation using the math library. Now in Jupyter Notebook, there is a very useful feature which allows us to quickly explore the offerings of the functionality of the respective object. So if I press the tab key at this point, I get a list of all the things I can now do with the math module. And if I scroll down, you can see I have something called pi. And if I select this and then run the code cell, I get the value of pi returned. In fact, I could use other functions from this module like performing a factorial calculation. So if I type math and then place a dot and then start typing factorial, you can see we have something called factorial appear. And if I enter 6 inside the parentheses, we perform the calculation 6 times 5 times 4 times 3 times 2 times 1. And we get 720. Now please don't worry if you've got slightly lost at this point. There's lots of terminology to get up to speed with, and it can sometimes be confusing when thrown terms like functions and methods and attributes and what the differences are, or even what this dot means in the code. All you need to take away from this video is that there are many libraries that can help us work with numbers more efficiently without having to build it ourselves. We're going to cover this in detail when we dive into the world of modules and packages, but before we get there, let's dive into the world of strings. Okay, so that concludes our coverage of lists, a very powerful data structure that allows us to store data in an efficient way that we can then access in numerous ways whenever we need it. We have now covered many useful list methods that help us when working with the list data structure. Now tap yourself on the back and take a deep breath. All of these list techniques will come in useful in so many projects. Before moving on to our next data structure, let's test your knowledge to see how much you've mastered with respect to lists. Let's now dive into our second data structure called the dictionary. So let's think about a real dictionary. We get words, which we can look up, and we can then obtain the respective definitions for those words. Now a Python dictionary is very similar in that we get what are known as keys, which can be thought of as the words in a dictionary, and these keys have associated values, which can be thought of as the definitions. So a Python dictionary have what are known as key-value pairs, and if we look up a specific key in the dictionary, we'll be able to see the associated value. So if, for example, we have a grocery store, which could have a dictionary which stores all the items that the store sells as keys, the value could represent the price that each item costs. So if I were to look up apples in the dictionary keys, I could obtain the value which represents the price for apples. Now, more formally speaking, a Python dictionary is an unordered collection of items, with each item of a dictionary having a key-value pair, as mentioned. So let's create our very first dictionary. In a similar way to how we created lists, we can first of all create a variable which will store our dictionary. So we'll call this my_dict. We can then put the equal sign, and to create a dictionary, all we need to do is put curly braces. So where we used square brackets for lists, we use curly braces for dictionaries. If I now pass in the my_dict variable into the type built-in function, we can see that we have created a dictionary object, and we're now ready to use this new data structure. In the coming videos, we'll find out exactly how we can use them and how we can modify them. So as we saw in the last video, creating a dictionary is as simple as placing items inside curly braces. And we can separate our items in our dictionary by using a comma, just like we did when we separated items in our list. Now each item has a key and a corresponding value that is expressed as a pair, and we've seen this termed as key-value pair. Now while values can be of any data type and can be repeated, keys must be of an immutable type. So this would include things like strings, numbers, or tuples, for example, and must be unique. So let's run through a few examples. We'll firstly create a dictionary where the keys are integer values. So we can type my_dict as our variable name, and we can set this equal to a set of curly braces. Inside the curly braces, we are going to add two items. The first item is going to have the key 1. And after the key value, we place a colon. We can then specify the value that is associated with the key 1. So for this example, we'll put the string banana. We can then separate our second item from our first item by putting a comma. So we'll put comma, and our second item in the dictionary will have the integer 2. We can then place a colon, and the string value that will be associated with this key will be pair. So in this example, we have a dictionary with two items. The first item has a key of 1 with the value banana. The second item has the key 2, and this has an associated value of pair. So keys can be integers, and in this example, our values are strings. Let's now create a second dictionary. So we can call this my_dict_2, and we'll set this equal to a dictionary, so we'll put curly braces, and our first item will have the key apple. Now because this key will be a string, we need to include this in single quotes. We can then put a colon, and we will then associate the value to be the cost of an apple, so we'll put the float 0.49. Once we're happy with this item, we can put a comma, and our second item will have the key guitar. We can then put a colon, and then we'll put the price 4.99. So our second dictionary here is slightly different in that we've utilised string values to represent the keys. Let's show one more example where we mix the keys. So we can put my_dict_3, and we'll set this to an empty dictionary. Our first item will have the key name, and we'll then put a colon, and the value will be Peter. Our second item will have an integer as the key, so we'll put 1. We'll then put a colon, and rather than putting floats, integers or strings as the value, we can utilise lists. So let's add a list as the value, and the list will contain 3 integers, 2, 3, and 4. So each of these dictionaries are valid dictionaries. Now you may remember from the last section we covered the zip function, where we stitched 2 lists together in which we obtain pairs of values in what are known as tuples. So let's recap. I'm first going to create a variable called names, and I'm going to set this equal to a list, and we'll include Jane, Kim, and Sam. We'll then create a variable called ages, and we'll set their ages to be 24, 52, and 32. We can then create a third variable which we'll call names_ages_list, and we'll set this equal to the zip function, in which we'll include names and ages, and as we know, this will bring back a zip object. So in order to turn this into a list, we wrap this inside the built-in list function. Now we don't just have to turn this into a list, we have the option to turn it into a dictionary. So we can create a variable called names_ages_dict, and we'll set this equal to the zip function in which we'll pass in names and ages as arguments, and this time we'll wrap this inside the built-in dict function. So as you can see, if we print out the names_ages_dict variable, we have a dictionary, which has been created by passing in two list objects into the zip function and then converting into a dict object, i.e. a dictionary, by using the built-in dict function. So a dictionary simply contains multiple items separated by a comma, with each item containing a key and a value. The keys must be immutable objects like strings and numbers, and must also be unique. The values can be anything such as single value items like integers or strings, or they can be data structures like lists, tuples, or even other dictionaries. Practice creating your own dictionaries so you're comfortable with the syntax. You need curly braces to define the dictionary, you need to separate each item with a comma, and each item needs a key-value pair which is separated by a colon. Now we've seen how to access elements from a list and from a string by passing in an index value into square brackets. Now while indexing is used with other data types to access values, a dictionary uses keys. Now keys can be used either inside square brackets, just like with indexing, or we can use the dictionary get method. So let's see some examples first using square brackets. If we first of all create a dictionary called names_ages and take the dictionary that we created in the last video of names and ages, we can first of all stipulate our names_ages variable, which we know is a dictionary object. We can then place square brackets after the variable name, and inside the square brackets we pass the key. So let's obtain the age of Jane. We can pass Jane inside square brackets, and when we run this code, we return 24. Now we could copy and paste this code and then place Kim inside square brackets. When we run this code, we obtain the value 52. So we can simply take a key, place it inside the square brackets to obtain the associated value. Now, if we were to place a value inside square brackets that does not exist as a key in the dictionary, we get a key error when we run the code. For example, if I were to pass the key Simon into square brackets, we run into a key error. Now, the second way we can obtain a value from a dictionary is by using the get method. So using the same syntax that we've seen when using methods on other data structures like lists, we can use dot notation. So we can type names_ages and then we can place a dot. We can then use the get method and then we can open up parentheses. Inside these parentheses, we need to stipulate the key that we're searching for. So if I were to put Sam inside the parentheses, we obtain the value 32. If I were to copy this code and then place Jane inside the parentheses, we get back 24. Now the difference between the get method and the square bracket syntax to access a value from a dictionary is with respect to the case where a key is not found. So if I were to type names_ages.get and then place Simon inside the parentheses, you can see that nothing is returned. In other words, the get method returns none if the key is not found. So we don't run into the same key error message when a key does not exist. So here we've seen two ways of being able to access elements from a dictionary. We can use square brackets and pass in a key. If the key doesn't exist, we'll run into a key error. The second method is by using the get method on the dictionary object. So we can place the variable name, .get, and then inside parentheses, pass the key name. If the key doesn't exist, the method will return none. Now dictionaries, just like lists, are mutable objects. So therefore, just like lists, their contents can be modified. Now we can add new items or change the value of existing items in a dictionary by using the assignment operator, i.e. the equal sign. Now there are some simple rules to acknowledge and follow. So let's take a look at some examples. Now firstly, if the key is already present in a dictionary, then the existing value will get updated. So let's create a quick dictionary. So we'll call the dictionary my_dict, and we'll set this equal to a dictionary, so we'll start curly braces, and our first item will be the key apple with the price of 49p. The second item will be banana with a price of 69p. And we'll finish with bread as the third key, with a price of £1.50. Now if I wanted to change the value that's associated with the key bread, all I need to do is first access the key, which we know is done by firstly putting the variable name, so my_dict, and then in square brackets I can place the key's name. So here I can place bread. Now because we're looking to change the value of bread, we can then put the assignment operator, i.e. the equal sign, and we can set this to a new value. So let's put £2.50. So here, because the key bread already exists in our original dictionary, the value will get updated to whatever we stipulate on the right hand side of the assignment operator. So when we now look at the variable my_dict, you can see that bread has been updated to £2.50 accordingly. Now secondly, in the case where the key is not present, a new key value pair will be added to the dictionary. So if we wanted to add a new item, let's say pair, we can put my_dict and pass the new key that we want to add to the dictionary. In this case, we'd put pair in single quotes. We can then assign this a value. So let's say that pairs cost 99p. We can put equals and then 0.99. When we now look at the values stored in my_dict, we can see that bread has been updated to 250 from the prior operation, and now we've added pair as a key and the associated value of 99p to the original dictionary. So changing elements is simply done by providing the key that you want to change and then stipulating the new value on the right hand side of an assignment operator. Adding elements is as simple as passing in a new key and then assigning the new key a value on the right hand side of the assignment operator. Now remember, the old value will be overwritten if the key already exists, so make sure it's an operation you want to perform before executing, as you may end up overwriting something that you don't intend to. So just take extra care when assigning something to an existing key. So as I keep saying, dictionaries are a type of data structure just like lists, and they are also mutable objects. So just like lists, we can now remove a particular item from a dictionary. Now, do you remember the pop method? Well, we can use it with dictionaries too. So this method removes an item based on the specified key that you provide, and it then returns the value. So let's see an example. We'll take our dictionary that we created in the last video. So as you can see, we have apple that costs 49p, banana 69p, bread £2.50 and pear 99p. Now seeing as we're using the pop method, we can access it using dot notation on the object itself. So we can put my_dict, then we can place the dot, then we can put pop with a set of parentheses. Now if I quickly take a look at the documentation, you can see here that it removes a specified key and returns the corresponding value. So what do you think we should be providing inside these parentheses? Well, it's the key name. So let's say we wanted to remove the item which has the key bread. We simply need to pass in bread into the parentheses. Now when we do this, it returns the value of the item. So when we run this, we can see that we obtain £2.50. Now because it returns a value, I am able to store this value inside of a variable if we wanted to use it in another part of our code. Now if the key that you provide is not found, and you only provide one argument into the pop method, a key error is raised. However, there is a way that we can avoid the key error by passing in a second argument into the parentheses. So the first argument will be the key that you are searching for. So let's, in this example, put butter. Now because we know butter doesn't exist, if we left it at this point, we would run into a key error, as seen on screen. However, if I pass in a second argument, this will then return the second value if the key is not found. So if we were to say return 50p if the key is not found, you can see now because butter is not found, we return 50p. So this is a way of avoiding the key error by returning back a value of choice. Now there is another pop method that we can use with the dictionary, which is called pop item. And the pop item method can be used to return an item from the dictionary. And the item returned will be the last in the dictionary. So if I was to rerun the original dictionary, so we have the full dictionary stored in my_dict, if I now type my_dict, then place the dot, and then put pop item, and then a set of parentheses. When we run this method, you can see that we return the item with the key pair and the value as 99p. If I were to run the pop item method again, we return the item with the key bread and the value £2.50. So this is a way of being able to remove an item and return it as a tuple. Now moving on, as we also saw with the list data structure, all items can be removed at once by using the clear method. So if we reset our dictionary, we can then put my_dict, we can then place a dot, and then we can put clear with a set of parentheses. This will remove all items from the dictionary, but it will not delete the dictionary in its entirety. So we can still access the my_dict variable as a dictionary object and place items in it later down the line, but after the clear method is executed, there will be nothing stored in that dictionary. Now in a similar vein, we also looked at the del keyword with the list object. And unsurprisingly, we can use the del keyword when working with dictionaries. So we can remove individual items by accessing them first. So let's refresh our dictionary. And the first thing we're going to do is access the key apple. So we can put my_dict, we can place square brackets, and inside the square brackets we can pass the key apple. Now once we're happy with the item that we've selected, we can just proceed this with the del keyword. When we now look at my_dict, we can see that apple has been removed from the dictionary. Now we can also use the del keyword to delete the entire dictionary itself. So if we were to now put del and then follow this with my_dict, which represents the complete dictionary object, when we now try to look in my_dict, you can see that we run into a name error, stating that name my_dict is not defined, which makes sense because we've deleted the entire variable which contained the dictionary object. So we can no longer reference this variable in our code. So we use very similar methods and syntax used with lists to remove items from a dictionary. Practice creating a dictionary and deleting items accordingly. Remember, the pop method will remove an item but return the value associated with that item, which you can then store in a variable and use later on. If you use the pop item method, this will remove the item and return it as a tuple, and it will remove an arbitrary item which is at the end of the dictionary. You can use the del keyword by specifying a specific item that you want to delete and precede the key that you've accessed with the del keyword. You can also delete the list in its entirety using del and then the variable name. Or if you wanted to still be able to access the dictionary object and add items to it later, you can clear all items from the dictionary by using the clear method, which will mean that your dictionary object stored in the variable will still be accessible later down the line. Now we've covered a few core methods so far to help us handle dictionary elements, but there are 3 other useful methods I want to share with you, all of which do a very similar thing. They help us obtain either all the keys at once, all the values at once, or all the items at once, i.e. both the keys and values. So let's see them in action. We'll start with the dictionary that we're familiar with, and we're then going to access the items method on the my_dict variable. So we can put my_dict, we can then place a dot, and then we can put items followed by a set of parentheses. When we run this, we get the following returned. Now, if I was to place this inside of the type built-in function, you can see that we have an object of the dict_items type, which is a set-like object. So what can we do with this? Now, if we think about it, as we can see in the previous result, we simply have a set of tuples inside of a list. So if we were to use the list built-in method at this point and wrap the my_dict.items method inside parentheses, we have now converted our dictionary into a list, and we've seen this in a prior video. So nothing new here. But how do we access just the keys? Well, we can use the keys method. So we can put my_dict.keys, and this brings back the following. So you can see here we have a list of the keys in our dictionary, but the object is of the type dict_keys. So we could pass this into the list built-in function, but this will simply turn this list of keys into a list object. And unsurprisingly, we have one final method, which is the .values method, which does the exact same thing, but this time it pulls back the values from the dictionary in list form, but it's in an object called dict_values. So we could once again pass this into the list built-in function to obtain a list of these values. Now obviously, once we have a list object, we can use all the methods that we've seen in the list section to now carry out any transformations that we want to. Now I just want to introduce a concept which we will cover in much more detail later in the course when we cover control flow, but it's the concept of looping. So these methods that we've just gone through come in very handy when we want to access all elements of a dictionary. So please don't worry about the syntax that I'm using here, just try to follow along with the concept. So if I start by typing for value in, and then place my_dict.values, what this will do is take every single value that it observes in the my_dict.values object. And if we print the value that's observed, you will see that we iterate through the dict values object and we print the value to the screen. So I'm able to access all of the values individually on which we could perform certain logic. Now, if I was interested in the keys, I could simply switch the word values for keys, and then we iterate through each of the keys. Finally, if I wanted to iterate through all of the items, I could change this method to be items, and then we print the items, i.e. the tuple representation of the key and value, to the screen. Now we will cover the concept of looping and the syntax required in much more detail in the section where we discuss control flow. But for now, you can take away that a dictionary has items and an item has a key and a value. We are able to iterate through a dictionary and get all the items, all the keys, or all of the values at once if desired, and the dictionary methods discussed here will help us do this. We will see these methods again later in the course, but hopefully this gives you an idea as to how these methods could come in handy. So in the final part of this dictionary section, I just want to cover dictionary membership and some other built-in functions that we can use with dictionaries. So let's first cover dictionary membership. Now you may remember we saw a way to find out whether a value existed in a list. Now we can do the exact same thing with dictionary keys. We can test to see if a key is in a dictionary or not using the in keyword. Now the thing to stress here is that the membership test is only for the keys and not for the values. So if we start with our my_dict dictionary, and if I just change the key apple to be custard, and we'll have the value as 2.99, you'll see why I've done this in a minute. You can see I can now test to see if the key custard is in my_dict. And you can see that we get the result true returned. Now if I was testing to see if grapes was in my_dict, you can see that we get false returned, as grapes is not a valid key in our my_dict dictionary. Now you can also use the not in operator in the same way that we saw in lists. So if I was to change this grapes membership test to be grapes not in my_dict, you can now see that we obtain true because it's not a key in the my_dict dictionary. So this is a way we can test to see if a key is in a dictionary. Now I just want to cover a few built-in functions that can come in useful when working with dictionaries. And the first one I want to show is one we've seen before called len. So if we were to put len, which is a built-in function, and then inside parentheses put our dictionary object, you can see that we get 4 returned. Now that's because the len function returns the length, i.e. the number of items in the dictionary. So it essentially counts the items between each comma of a dictionary. Now we can also use the sorted built-in method to return a new sorted list of the keys within the dictionary. So you can see here, if I pass in my_dict to the sorted built-in function, we get a list of keys, but they're now ordered in alphabetical order. So custard is returned at index 2, as opposed to showing first in our original dictionary definition. Now the next built-in function I want to share with you is known as the all built-in function. And what the all built-in function does is it will return true if all the keys within a dictionary are true. Now that doesn't mean we can't contain strings, because if I pass a string of custard into the bool of built-in data type to see what value we get, you can see we obtain true. So this can be confusing at first, but objects such as none or a boolean of false or 0 would come back as false. So providing it's not one of these values, the all built-in function will return true if all the keys of the dictionary are true. Now it's also worth noting that if the dictionary is empty, the all built-in function will also return true. And this is because it doesn't contain any key in the dictionary that is false. Now we also have the any built-in function, which will return true if any key in the dictionary is true. So if I were to actually change one of the items in the dictionary to be false, you can see that we still obtain the value true because we have at least one other key in the dictionary which is true in nature. Now if the dictionary is empty, when we use the any built-in function, it will return false. So a few built-in functions here to keep in mind as we progress through the course. Some are certainly used more than others, but you'll never quite know when you'll need them, so it's always worth having these functions in your mind just in case a use case for them pops up. We are making great progress through the different data structures, and this section dives into another data structure known as tuples. Now a tuple in Python is similar to a list, which we've covered in a lot of detail already. The difference between the two is that we cannot change the elements of a tuple once it is assigned, whereas we can change the elements of a list. So you may be thinking, well, if we can't change the elements once they've been assigned, why would we ever use a tuple? Well, sometimes we want to store data that can't be changed or manipulated, and this is where tuples would come in handy. We'll be discussing tuples versus lists later in this section. Now we will be going over some familiar concepts in this section as we've seen a lot of the syntax before, but this will be a way of reinforcing our learning. So let's start by seeing how we create an empty tuple. So we can start by creating a variable which will store the tuple object. So we can put my underscore tuple. We can then put an assignment operator, i.e. the equal sign, and then we can put brackets. So notice here these are not square brackets, they're not curly braces, they are standard brackets. Now if we put the my underscore tuple variable into the built-in type function, you can see we've created a variable of the type tuple. In the next video, we'll see what we can include inside of tuples. Now a tuple is created by placing all the items or elements inside of the brackets, and we separate each element by a comma, just like we saw with lists. So we could start by typing my underscore tuple, and we can set this to a set of brackets, and inside the brackets we can have integers, so we can put 1, 2 and 3. If we run this, this would be a valid tuple. We can mix data types, so we can also have my underscore tuple underscore 1, and we can set this equal to brackets, and then we can have an integer as the first element, so let's put 1. We could then have a string as the second element, so let's put the word hello. And then we could have a floating point number as the third element, so we could put 2.5. When we run the myTuple1 variable, we get a valid tuple. Now we can also have nested elements inside of our tuple. So if we now create a variable called my underscore tuple underscore 2, we can set this equal to a set of parentheses, and then the first element may be a string, so we can put football. The second element may be another data structure like a list, so we can put in square brackets some integers, so 1, 2, 3. And then the last element, we can include a nested tuple, so we can put another set of brackets, and inside these brackets we can put our nested tuple elements. So we could have integers, mixed data types, strings, whatever we want. So let's just put 2 strings, hello and goodbye. When we print out my tuple 2, we get a valid tuple returned. Now a tuple can also be created without using the parentheses. And this has a special term called tuple packing. So let's see an example as to how this works. So we can have a tuple called my underscore tuple underscore 3. And we can simply put elements to the right hand side of our assignment operator separated by a comma, but just remove the parentheses. So let's put 1, comma, then we'll put a string of Spain, then we'll put a comma, and then we'll put a list of integers 1, 2 and 3. Now when I print my underscore tuple underscore 3, you can see that we get a tuple returned. So even though the parentheses are optional, it is good practice to use them, as when you see the brackets, it becomes more clear as to what the code is doing. Now interestingly, creating a tuple with one element may not work in the way you expect it to. So for example, if we have my underscore tuple underscore 4, and we set this equal to a set of parentheses, and inside the parentheses we put the string hello. When we now print out the type of my underscore tuple underscore 4, you'll notice that we get a string object back. So in order to create a tuple representation of one element, inside the brackets we actually need to put a comma after the first element, even though we're not going to put a second element. When we now print the type of my underscore tuple underscore 4, we return the type tuple. Now once again, parentheses are optional in this case, so we could remove the parentheses, but we'd still need to put a comma after the first element in order for the type to be recognized as a tuple. So in a very similar way to lists, we simply add elements to our brackets and we separate them by a comma. We can include any data type or structure, so integers, floating point numbers and strings, and we can even include other data structures such as lists or tuples. Now I have some good news. The way we access tuple elements is the same as the way we access list elements. So this video should be more of a refresher, so let's remind ourselves how we access elements. Firstly, we can use indexing. So we can use the index operator, which is square brackets, to access an item in a tuple. So here I've created a tuple with 1, 2, 3, 4, 5 as separate elements. I then have a list element with the integers 6, 7 and 8, and then I have a tuple element with the numbers 9, 10 and 11. So if I wanted to access the number 5 in this tuple, I could put my underscore tuple, and I could follow this with a set of square brackets. Now to access number 5, I would need to put in index 4, seeing as indexing starts from 0. When I then run this code, we get 5 returned. Now if we count the number of elements in this tuple, we have 7 in total. 5 integers at the start, 1 list element and 1 tuple element. So if I was to try to access my underscore tuple and provide an index which is out of range, i.e. if we try to access the element at index 7, you can see we run into an index error, telling us that the tuple index is out of range. So therefore, when you're trying to access an element, make sure that the index is in range, otherwise you'll run into an index error. Also remember that the index must be an integer, so we can't use floats or other types. So if we put my underscore tuple and inside square brackets we put 2.5, this will bring back a type error stating that the tuple indices must be integers or slices, not floating point numbers. Okay, so moving on. Can you remember what we'd need to put in order to access the number 10? We can use nested indexing. So here, the number 10 resides in the last element of the tuple, which in itself is a nested tuple. So if we type my underscore tuple and inside square brackets we put index 6, we return the full tuple, i.e. 9, 10 and 11. Now if I chain another indexing operation to this index operation and put square brackets 1, seeing as 10 is the second element within this tuple, you can see we obtain the number 10. So we're able to access nested structures inside of a tuple by using nested indexing, just like we would if we were accessing nested lists. Now, if you remember, we can also use negative indexing. So let's say we wanted to access the number 11. How do we go about doing this? Well, seeing as the nested tuple is the last element in our main tuple, we can put my underscore tuple and inside square brackets we could put -1. Now -1 refers to the last item and -2 would refer to the second last item, and so on. So if we now wanted to access number 11, we could chain an indexing operation where we once again put -1. So we take the last element in the main tuple, and then we take the last element in the nested tuple. When we run the code, we bring back the number 11. Now if you also remember, we can slice lists by passing in a starting index and an ending index. So if we were to try to access the numbers 1, 2 and 3, we can have my underscore tuple, and inside square brackets we can put the starting element, which we know is index 0, and we can then put a colon. We then want to go up to the third element, so we'd place index 3, seeing as the third element is index 2, and we go up to, but not including, the end index. When we run this, we get the values 1, 2 and 3. Now inside this operation, if 0 is our first index, we can actually remove the reference to the starting value and simply put a colon. This will simply mean from the start of the sequence. And if we were to remove the end index value within the slicing operation, this will go up to the very end. So if we were to put my underscore tuple and inside square brackets, we simply put a colon. When we run this, we get all the elements from 1 all the way up to the last item in the tuple, which is that nested tuple. With slicing operations as well, we can use negative indexing. So if we wanted to go from the third item from the end all the way to the end, we could put my underscore tuple, and then inside square brackets, if we put -3, which we know would be the integer 5, and then we put a colon, this will grab the element 5, the list with 6, 7 and 8, and the tuple with 9, 10 and 11. So hopefully this was a bit of a refresher as to how we can use slicing and indexing on tuples. It takes the exact same form as lists, so it should be something you're comfortable with already. Now so far we've seen a lot of similarities between tuples and lists, but unlike lists, tuples are immutable. Now that means that elements of a tuple cannot be changed once they've been assigned, whereas we can change elements of a list. So for example, let's take the tuple that we created in the last video. So if we access the first element of this tuple, we would put my_tuple, and inside square brackets we would put 0. Now if this was a list, we can then put the assignment operator and then choose what to assign this element in the list. However, with tuples, if we try to assign this a new value, for example the string hello, you can see we run into a type error, telling us that the tuple object does not support item assignment. This is what we mean by immutable. The elements cannot be changed. However, if the element inside the tuple itself is a mutable data type like a list, i.e. the nested item, then the nested item can be changed. So you can see here we have a list inside of this tuple. So if we access this list, we can put my_tuple, and in square brackets we would put index 5, seeing as it's the 6th element. This will bring back the list. If we now want to change the value 8 to be the value 80, we can then use nested indexing by placing another set of square brackets and then putting the index 2, as 8 is the 3rd element in the nested list. If we assign this to be the value of 80, when we take a look at my_tuple, we can see that the value 8 inside of the mutable list object has been changed to 80. Now let's think about this for a second. Why can we do this? Well, if we think about it, as soon as we access my_tuple and put in index 5 in square brackets, we have returned a list object. So we can now chain list methods to the end of this indexing because we're now working with a list object. So if I wanted to add an element to this mutable list, even though it resides inside of a tuple, we can do so. So if I was to put my_tuple square brackets 5 and then put dot append, we can add another item to this list. So let's add the value 100. When we now run my_tuple, you can see that 100 has been appended to the list object which resides inside the tuple. So note here that if we try to change an element inside of a tuple element, we will get a type error, as tuples are immutable objects. Whereas if the tuple itself contains an element which is of a mutable data type like a list, we're able to change the items in that element specifically. Now, if we wanted to change the values of a tuple, the way we can change them is by reassigning values. So here, if I type my tuple, you can see we have a long list which starts with 5 integers. Now, if I were to put my_tuple and then assign this a new tuple which contains 3 strings, so we'll put 1, 2, and 3. We have now changed the items stored inside my_tuple, but this is reassigning a completely new tuple to this variable. So we haven't changed the original object, we've actually assigned it a new tuple. Now a couple of other things we can do. If I type out my tuple, I have 3 elements within it. Now I can use the plus operator to add more elements to it. So if I put my_tuple and then put plus, I can then add 3 new items to our tuple by first providing brackets and then put in strings such as 4, 5, and 6. Now when we use the plus operator to combine 2 tuples, it's known as concatenation. So what we've actually done here is brought back a new tuple. This won't be stored anywhere unless we assign this to a new variable. So once again, we haven't changed the original tuple, we've simply concatenated another tuple, but then we would need to reassign this to a variable, so let's call it my_tuple underscore 1. And now whenever we access this new variable, we have the 6 elements accordingly. Now another thing we can do is use the star syntax to bring back a new tuple. So for example, if I take the original my underscore tuple, which has 1, 2, and 3 stored inside of it as strings, if I multiply this by 2, we get the sequence of 1, 2, and 3 twice within our tuple. And if we wanted to, we could assign this to a new variable and then use it later in our code. So remember, tuples themselves are immutable objects. We're unable to change the elements once they've been assigned. However, if there is a nested element inside of the tuple which is of a mutable nature, such as a list, we're able to change the list's elements. For tuples, we can use concatenation to add values to our tuple, but we'd need to reassign or assign this to a variable. And the same with the multiplication, we're able to repeat elements in a tuple, but this brings back a new tuple, and we need to reassign or assign this to a variable in order to use it later in our code. As we've just discussed, we cannot change the elements in a tuple. That also means we can't remove or delete items from a tuple. So this video will be slightly shorter than all the rest. So for example, if we access the first element by typing my tuple square brackets 0, and then putting the del keyword before it, you can see we run into a type error telling us that the tuple object doesn't support item deletion. But it is possible to delete a tuple in its entirety. So if we were to put del followed by my underscore tuple, if we now try to reference my underscore tuple, we can see that the name my tuple is not defined. So we've deleted the entire tuple object and it can no longer be referenced anywhere in our code. So to summarize, we can't delete specific elements from a tuple, but we can delete the tuple object in its entirety by preceding the variable name which stores the tuple object with the keyword del. Now, seeing as tuples are immutable objects, there isn't too much we can do with them. So the good news is there are actually only 2 methods we can call on a tuple object. So let's first of all create my underscore tuple, and we'll set this equal to a tuple of integers, and we'll put 1, 1, 1, 1, 2, 3, 4, and then 1 and 1. Now the 2 methods we have available to us are count and index. So if we first of all call the count method on the myTuple variable which stores a tuple object, inside these parentheses we can pass in the value that we want to be counted within the tuple. So if we put the integer 1 as an example, we return 6 as there are 6 elements inside of this tuple that are of the integer 1. So inside this count method we can pass in a value, whether that be an integer or a string, and it will count the number of elements that equal that value. Now the second method we can call is the index method, and this will bring back the index of the first occurrence of the value that you put within the parentheses. So if we put my underscore tuple, then our dot, then index, and then inside square brackets put the value 2. Before we run this, we can see that the index of the value 2 is actually index 4 because it's element 5. So when we run this code, we do indeed bring back the index value 4. Now if I change this 2 to be the value 1, you can see that we get index 0 as it brings back the index of the first occurrence of this value. Now we've seen before that we can pass in a second argument to the index parameter, which is whereabouts in the sequence we want to start the method from. So if I put 5 as the second argument, you can see that it brings back index 7. This is because it's starting from element 6 and the first occurrence of 1 then occurs where that occurrence of 1 is at index 7. So we can either pass in one argument, which will pick up the first occurrence of the value from the start of the tuple, or we can pass in a second argument in addition to the first, which will change whereabouts the search starts from. Now one other thing I want to show you, which we've already seen before, is tuple membership. So we can see whether a value exists in a tuple or not in a very similar way to how we've seen with lists. And this is done by using the in operator. So we can put 1 in my tuple, and of course this is true, there are many of them. We can then put 5 in my tuple, and because 5 does not exist as an element inside this tuple, it brings back false. Now we can also use the not in operator, so if I change 5 in my tuple to be 5 not in my tuple, we then obtain the value true. And this comes in very useful when it comes to conditional statements, which we'll see in a subsequent section. So remember, there are two methods we can use: count, which counts the value that you stipulate within the tuple itself, and index, which brings back the first occurrence of the value that you stipulate back as an index. We can also use tuple membership, where we simply use the in operator or not in operator to ascertain whether a value is inside the tuple or not. Now you may recall from a prior video the concept of tuple packing. If not, don't worry, let me quickly remind you. Now I can create a variable called my_tuple, and I'm able to create a tuple by simply putting the values that I want to include. So I can put 1, 2, then a string hello, then a floating point number of 2.5. Now when I print out my_tuple, you can see we return a tuple based on the brackets, but just to prove it, I can put my tuple inside of the built-in type function, and we get tuple returned. Now once we have all of the elements inside the tuple, we can carry out a reverse operation which unpacks the elements and stores them in individual variables. So seeing as we have 4 elements inside this tuple, I'm able to create 4 variable names on the left-hand side of an assignment operator. So if I simply put A, B, C and D separated by commas, I can set this equal to my_tuple. And what this will do is it will take the first element in the tuple and assign it to the variable name A. The second element will be assigned to B, and so on. So if I now take a look and see what's stored in the variable named A, you can see we get 1 returned. And if I take a look what's stored in C, we get hello, D, we get 2.5. Now one thing to note here is that we need to provide the same amount of variables on the left-hand side of our assignment operator compared to the number of elements stored in the tuple. So seeing as this tuple has 4 elements, if I were to only stipulate 3 variable names on the left-hand side of the equal sign, you can see we run into a value error, and it tells us that there are too many values to unpack. We're expecting 3 based on the stipulation of 3 variable names, but there are actually 4 inside of the tuple. So tuple unpacking is a very useful way of being able to take elements stored inside of a tuple and assigning them to different variable names. So practice creating a tuple using tuple packing, and then unpacking into different variable names based on the number of elements that are inside the tuple. Now sometimes it can be a little confusing as to when to use lists and when to use tuples. Since tuples are quite similar to lists, both of them are used in similar situations. However, there are certain advantages of implementing a tuple over a list. So let me give you some of the main advantages. Now firstly, we generally use tuples for heterogeneous data types, which basically means we store different data types within them. Now lists, however, are usually used for homogeneous data types, so types which are similar or the same in nature. Now this will become very apparent if you start diving into the world of data analytics using libraries such as pandas, but we can save this for another course. So when storing items in a tuple or a list, work out whether they will store different types. If it's the same type, then a list will usually be the better option. If they are of a different type, then a tuple usually works better. Now secondly, since tuples are immutable, iterating through a tuple is actually faster to perform than iterating through a list. Now the difference is hardly noticeable on small datasets, but it can save time on larger stores of data. Now we will explore the concept of iteration when we get to the control flow section, so keep this performance benefit in mind. Now thirdly, tuples that contain immutable elements, so things like integers or strings, can be used as a key for a dictionary. So let me show you what I mean. If I create a dictionary called my_dict, and I set this to a set of curly braces, inside of this dictionary I can now type a key and a value. For the key, I'm going to create a tuple with the values 1, 2, and 3. I can then put a colon, and for the value, I will simply put the string hello. When we run my_dict, you can see that we get a valid dictionary. And if I was to try to access the value that's associated with the tuple with the values 1, 2, 3, I'm able to place this inside square brackets, and you can see that we obtain the value hello. Now, if I go back up to the original dictionary definition and replace the brackets for square brackets, you can see we run into a type error, and it states that we're working with an unhashable type, list. Now, I've included some documentation in the resources section if you're keen to explore what this error means. Now, a simple way to think of when to use a tuple versus a list is as follows. Do I want the data inside the data structure to change? If you have data that doesn't change, implementing it as a tuple will guarantee that it remains write protected, as it is immutable and you can't change it. If you want more flexibility and you want the values inside of the data structure to change, then storing in a list would be better as they are mutable objects. Now, you may be pleased to know that we are about to cover our last data structure before moving on to some more exciting programming concepts such as control flow that make our programs come to life. But first things first, let's understand sets so we can use them in our programs when use cases crop up. So what is a set? Well, a set is simply an unordered collection of items where every set element, i.e. the item in a set, is unique. In other words, you'll never find a duplicate value in a set. Now, every element in a set must be immutable in nature. So as you know, this means it should contain things like strings and integers, for example, as these cannot be changed. However, a set itself, i.e. the data structure, is actually immutable, so we can perform more methods on them than we observed with tuples. For example, we can add or remove items to and from a set. Now, sets can also be used to perform mathematical set operations like union, intersection, and symmetric difference, all of which we will cover later in this section. Now, creating an empty set isn't the same as creating an empty list or an empty dictionary by simply placing a set of brackets, for example. So let's find out in the next video how we create sets as well as how we create an empty set. So as we've mentioned, sets are mutable. However, since they are unordered collection of items, indexing has no meaning. So with lists, seeing as they are sequenced, we can specify an index to bring back an item from the sequenced order. Sets, on the other hand, are unordered, so there is no concept of indexing. So with this in mind, we cannot access or change an element of a set by indexing or slicing. The set data type does not support it. So just to prove this, let's create a very simple set with the integers 1, 2, and 3. If we now try to access the first element in this set, i.e. the number 1, you would think we might be able to put my_set, open square brackets, and pass in index 0. But seeing as they are an unordered collection of items, and indexing therefore has no meaning, we get back a type error telling us that the set object is not subscriptable. In other words, we can't use indexing or slicing operations. So with that being said, how can we add an element to a set? Well, if we want to add a single element, we can do this using the add method. So if we put my_set and then utilize dot notation and place our add method afterwards, we can then put the element we want to add inside of the parentheses. So if we put the integer 4 and then take a look at what's stored inside my_set, you can see that 4 has been added to our set. Now the add method is a way of adding a single element, but if we wanted to add multiple elements, we're able to do this by utilizing the update method. Now the update method can take tuples, lists, strings, or other sets as its arguments. but in all cases, any duplicates you include inside of these data structures will be removed. So let's take a look at a couple of examples. If we now try to add the integers 5, 6, and 7 by passing them inside of a list inside of the update method's parentheses, you can see that 5, 6, and 7 have been added to our my_set variable. And it's the elements inside of the list that have been added, not the list itself, because we know that lists can't actually be included inside of a set, seeing as they are mutable objects. Now, if we wanted to, we could pass inside of the update method's parentheses a list, so we could have 8 and 9, and then we could also pass in another set, so we could put 1, 4, and 10. Now, if we print out my_set, all of the elements have been included accordingly. However, where there are duplicates, they have not been included. So you can see here 1 and 4 haven't been duplicated, but the number 10 has been included in our set. So to summarize, sets do not have a concept of indexing. To add a single element, we can use the add method, and to add multiple elements, we can use the update method. So let's now move on to some set operations. Sets can be used to carry out mathematical set operations like union, intersection, difference, and symmetric difference. Now we can do this by using operators, so a specific symbol, or we can utilize specific methods, which we will observe in a few examples. So let's suppose we have two simple sets of integers, and we'll store the first set in a variable called a, and we'll have this span from 1 to 5. And the second set we'll label b, and we'll have this set spanning from 4 to 8. So two sets with 5 integers each. Now upon observation, we can see that the integers 1, 2, and 3 only exist in set A. 6, 7, and 8 only exist in set B, and 4 and 5 exist in both sets A and B. Now, if we were to depict this in Venn diagram form, it would look something like the following. Now, the left-hand segment, which is labelled A, would relate to those items that are only included in A. The part on the right section labelled B would relate to those items only included in B. And the middle section would relate to those items that are shared in both A and B. So if we were to perform a union on both A and B, this would mean we bring back the items from each segment into a single set, i.e. the left segment, the right segment, and the piece in the middle. And the way we can perform this is firstly by utilising an operator, which is the pipe symbol, the symbol that is a vertical line, and we place this in between the variable names containing our sets. So we could put A pipe B, and when we run this code, we get a new set returned with the integers from 1 through to 8, with the duplicate values removed accordingly. So we only see the elements 4 and 5 written once. So very simple to perform. We can also get the same result by using the union method. And seeing as the result will always bring back each value from each segment, it doesn't matter what set we pass in as a variable into the parentheses. Let me show you what I mean. So if I start with the variable labelled A, which we know is a set object, and then place a dot, we can then put the union method, and inside the parentheses we can place the second set we want to union. So in this instance it would be variable B. When we run this code, we get back the result with integers from 1 to 8, just like we saw when using the pipe operator. And if I change this so we call the method on variable B and pass in A into the parentheses, we get the same result. So a union operation will combine two sets together and take all the values from both sets and bring back a new set without any duplicates. You can use an operator, which is the pipe symbol, or you can use the union method in which you pass a second set into the parentheses. The next set operation we're going to cover is known as set intersection. And set intersection can be visualized as follows. It brings back the middle area, i.e. the middle intersection where both sets cross over. And we can perform an intersection operation by using the AND operator, i.e. the ampersand symbol, and we can also achieve the same result by using the intersection method. So let's see a couple of examples. If we use the two sets created in the prior video, i.e. A containing integers 1 to 5 and B containing integers 4 to 8, if we type A ampersand B, you can see that we bring back 4 and 5, as these integers are shared in both sets A and B. Now, because the intersection relates to items that are shared, it doesn't matter how we call the intersection method. So if we call the intersection method on our A variable, and then inside parentheses pass in set B, we get the same result showing 4 and 5. If we were to call the intersection method on variable B and pass in set A into the parentheses, we also bring back 4 and 5. And we could then save this in a separate variable in order to use elsewhere in our code. So set intersection enables us to combine two sets and obtain the values that are shared in both. Now the final set operation we're going to observe is known as symmetric difference. And what symmetric difference allows us to see are those items that are included in either set A or B, but if they are shared, we will not show them in our result. And the way we can perform symmetric difference is by using the caret operator, i.e. the little arrow that points up. And the same can be accomplished using the symmetric underscore difference method. So let's see it in action. Seeing as we know that items 4 and 5 are shared between sets A and B, these would be the values we expect to be removed from our final result. So if we put A caret B, you can see we get a result set 1, 2, 3, which is from set A, and then 6, 7, and 8 from set B. 4 and 5, seeing as they are shared values, will not be included in our output. Now, because there is only one result set that can be obtained, it doesn't matter what we call the symmetric underscore difference method on, it will obtain the same result. So if we put A dot symmetric underscore difference and then pass in B to the parentheses, we get 1, 2, 3, 6, 7, and 8. And if we were to also call the symmetric underscore difference method on B and then pass in A into the parentheses, we once again get 1, 2, 3, 6, 7, and 8. So the symmetric difference operator allows us to obtain the values from both sets, but those values which are shared will not be included in our final result. Okay, so let's quickly take a look at some useful built-in functions that we can use with sets. So if we start with a set called A, which is a set of integers from 1 to 10 in a random order, we can first of all utilize the built-in len function, which we know brings a count of the number of elements contained within the data structure. So if we put len brackets A, we can see that we get back the result 10, which tells us there are 10 elements inside of this set. We can also utilize a built-in function called max, and what this will do is it will find the maximum value within the set. So if we pass in A into the built-in max function, we get 10 returned, but this time it refers to the number 10 as opposed to the count of items. If we use the opposite function, which is min, we can pass A into the parentheses, and this will bring back the value 1 because 1 is the smallest integer within this set. We can also use the built-in sorted method, which we've seen when working with lists, and what this will do is return a new list containing all of the items from the set in ascending order. But we can also turn this into descending order by passing in a second argument, as we've seen previously. So if we run sorted and then put A inside brackets, we get 1 through to 10 in ascending order. Now we can also use the built-in sum method, so if we pass in set A into the parentheses, we get the result 55 returned, which is simply the sum of 1 plus 2 plus 3 all the way through to 10. Now we can also, like we've seen with lists, tuples and dictionaries, perform membership tests. So if we want to check if the integer 1 is in the set that we've stored in variable a, we can put 1 in a, utilising that in operator, and we can see we return the result true because 1 is indeed in the set stored in a. If we put 11 in a, you can see we obtain false as we only go up to 10. Now if we put 11 not in a, because 11 is not in a, it evaluates to true, hence we obtain a true result. So a few built-in functions here that we can use with sets that can come in very useful, and we could also perform membership testing like we've seen with other data structures. In the last video, we introduced the concept of lambda functions, which are simply functions that we define with a number of parameters. We include an expression, and we can then assign this anonymous function to a variable, which then stores this lambda function object. Now we can use lambda functions in conjunction with other functions that take in a function as an argument. And the first function we're going to look at is the filter function. Now the filter function is a built-in Python function. So if I type out filter and then put a set of parentheses and then take a look at the documentation that supports this, you can see that the filter function takes in a function and then it takes in an iterable. And you can see that we will then return an iterator yielding those items of iterable from which function is true. So what does this mean? Well, basically, this means the first parameter will take in a function. The second parameter will be an iterable, so a list, for example. And then when we run this, each item in the iterable will be sent into the function, and if it evaluates to true based on the expression, the result is returned. So let's see an example where we have a list, and we'll call this num_list, and inside this list, we'll store integers from 1 to 10. So this will be our iterable, and we're going to pass this as the second item in our filter function. Now the first parameter is a function, so I'm going to define a function, and my intention here is to filter out the even numbers from this list and return those even numbers as a new list. So I'm going to put lambda and then num, which is what I expect each of these items in the iterable to be passed into when we run the filter function. I'm then going to put a colon, and then I'm going to put in brackets num modulo 2 is equal to 0. So this is my expression, and therefore when we pass in num into this expression, it's either going to evaluate to true or it's going to evaluate to false. So when I run this code block, you can see that it relates to a lambda function with a single parameter called num. So what I can now do is use my filter function and pass in these two lines of code into the respective parameters. So if I put filter and then open a set of brackets, I can copy and paste my function code and place it as my first parameter. I can then put a comma, and the second parameter I can include my iterable. So I can simply type num_list. Now if we run this line of code, you'll see that we bring back a filter object with its respective location in memory, which is obviously very difficult for us to see the result, but as we've seen earlier in the course, in order to convert this into a list, we can pass this into the built-in list function. So if I wrap this in the list function, you can see that when I press return, we do indeed bring back 2, 4, 6, 8, and 10, which are the even numbers from our num_list. And we could then assign this to a variable called even_nums, and then we can then use this list in subsequent parts of our code. So hopefully not too tricky to understand, the filter function is a function that takes in two items. The first item will be a function, and this is where the lambda function is a good option. The second parameter is an iterable, and for each item in the iterable, it will be passed into the function and will be evaluated accordingly. If it evaluates to true, it will be filtered accordingly, and we can then pass this into the list object. Okay, so moving on to the map function. How does the map function work? Well, it's very similar to the filter function, But this time, what the map function will do is take every item in the iterable and pass it into the function, where the function's expression performs some kind of action. So it won't evaluate to true or false and filter items, but it will perform some form of logic and then it will be returned accordingly. So let's start with our iterable, and we'll define this as a list called odd_nums, and we'll set this equal to odd numbers from 1 through to 15. We can then create our function. So our function in this case is simply going to double the numbers within this list. So we're going to put lambda and then num. We can then put a colon, and then our expression will be num multiplied by 2. Now we have these two bits of information, we can pass them into the map function. So we can put map, and then the first parameter will be the function itself. So we can put lambda num times 2. And then we can put a comma, and the second parameter will be the iterable, so we can pass in odd_nums. Now when I run this code, you can see that we store a map object at the respective location in memory here. So in order to convert this into a readable list, we can pass this into the built-in list function. And when we run this, you can see that we obtain a new list which doubles every number from the odd_nums list. And if we wanted to, we could assign this to a variable for onward use. Now sometimes it's cleaner to compartmentalize your code, so what you may want to do in this instance is assign your list to a variable called odd_nums and assign your function to a variable called double to give it some form of meaning. I can then delete the lambda function inside the map function, and I can replace this with the variable name double. And when we run this, we get the same result. And this to many is a lot easier to see because you can then see that the map function takes in two parameters, the first one being the function, which we can see is defined above, and the second one being the iterable, which we can also see is defined above. So in this video we've seen how we can pass in lambda functions into other built-in functions such as filter and map. Now we have already learnt so many functions throughout the course so far, but we're about to embark on 6 different projects, and I feel like there are a couple of functions that will be very useful for you to know before you start. So let me quickly walk through what these are. First of all, there is a Jupyter Notebook specific function that is very useful for making your output a lot cleaner. And this function is called clear_output. And the way we can use it is as follows. We first of all need to import it into our notebook. So we can put from ipython.display import clear_output. And once we've imported this function, we're then able to use it in our code. So let's now put this in a simple example. Let's say I print the string hello. When I run this code, we get hello printed to the screen, no surprises. If I then follow this line of code and print bye, we then get hello on one line and bye printed to the next line. I could then print an empty string, and on the 4th line I could print some space, then a pipe symbol, then some space, another pipe symbol, and some space. And if I print this, we get hello, bye, an empty string, and then the space and pipe symbol combination. Now, if I wanted to clear this specific output so that we did not see any of this on the screen, I'm able to call clear_output and then place some parentheses. So if I now run the code at this point, hello would have been printed to the screen, then bye, then an empty string, then our space and the pipe symbols, and then we execute the clear_output, which is why the output shows nothing. If I then follow this function with another print statement which prints coding to the screen, when I run this code cell in its entirety, we end up only printing coding to the screen because the output was cleared on the 5th line. Now, if we were to set variables or define functions and then clear the output, it doesn't remove the definitions that you've previously stated, it simply just clears whatever is printed to the screen. So this can be very useful in keeping any output that you produce very neat and tidy, especially when using loops in your code. So keep this in mind for the upcoming projects. Another useful capability is to generate random selections, and we're able to do this by using the random library. So first of all, just like the clear_output function, we can import random, and we can then call functions from this library. And the first function I want to show you is the ability to generate a random integer between two numbers. So the way we can do this is by first of all calling upon the library, so we can put random. We can then place a dot, and then we're going to access a method known as randint. We can then open parentheses. Now at this point, if I were to open up the documentation, you can see that randint accepts two arguments, a and b. And you can see here in the docstring that this method would then return a random integer in the range a and b, including both endpoints. So if I were to put 0 as argument a, comma, and then 10 as argument b, when I run this code cell numerous times, you can see that we're generating a random integer between these two numbers. We don't get numbers less than 0, and we don't get numbers more than 10. So a nice way of being able to generate a random integer between two numbers. And just as an example, this could come in useful if you're trying to randomize what player goes first when playing a game. Now a second method from the random module that I'd like to introduce you to is known as choice. So if I put random.choice and then open up the documentation, you can see that the choice method accepts a sequence. And the docstring states that this method would then choose a random element from a non-empty sequence. And the sequence that we pass in as the argument is up to us. So let's say in parentheses, I were to pass in a list. And this list is going to contain 3 items, A, B, and C. So with A, B, and C now passed in as the sequence, when I run this code cell, you can see that the computer is randomly selecting either A, B, and C from the sequence. And if I were to put this in an example, let's say that we were playing the computer at a game of rock, paper, scissors, where the computer had to select either rock, paper, or scissors. This could be a good option in order to generate a random selection from a predefined sequence. So keep this in mind when working through the upcoming projects. These are the 3 pieces of functionality I wanted to introduce you to just before you dive into the upcoming projects. The first project we're going to tackle together is a number guessing game, so I'll see you inside the next video. Welcome to the number guessing game project. In this project, we'll create a number guessing game in which the computer will generate a random number. We will then get the player of the game to submit a guess. Now the guess needs to be compared to the number that the computer has generated randomly, and if a guess is too high, the player should get notified via a message. And if it's too low, the player should also be told so. Now if the player guesses correctly, the player should be congratulated. Now a player should only get 5 guesses in this game, otherwise it would be too easy. Once the guesses run out, the game is over. And the final feature we want to include in our game is to ask a player whether they want to play again. If they do, we replay the game. If they don't, we should break out of the game. Now you have learnt everything you need to know in order to produce code that will address this project. The chances are that if you go and try to code this up yourself now, we will produce different code. But this is absolutely fine. In fact, it's expected. There is no single right way to code this solution. There may be cleaner ways to code the solution, but that's not what the goal of this project is. We're looking to bring together the knowledge that we've learnt in order to construct a final game, and it's the problem-solving element that we want to focus on. If we break this project down into smaller problem statements, it becomes easier to digest and tackle. Give this project your best go without any help. When you feel like you can't go any further and you get stuck, then feel free to look at the solution video that I've put together in the next video. That being said, when you go through the solution video, try to pause it along the way and code it up yourself. Really try to understand what each part of the code is doing to get a full understanding as to how this application can be coded in its entirety. Good luck, and I'll see you in the solution video. Hi everyone, and welcome to the third project in which we're going to be developing a fitness app which shows us some body statistics. It will help tell us whether our weight is healthy, and it will also allow us to see how many calories we should be consuming in order to meet certain weight goals. Now, some of us may want to maintain our weight, some of us may want to lose weight, and some of us may want to put weight on. And this app will help us determine how many calories we should be consuming based on our own information. So Fitness Fan Limited have asked us to create a fitness app to help their customers. The application should allow a user to observe their BMI, which is known as the body mass index, and the respective rating. More on this shortly. They should be able to observe their BMR, which stands for their basal metabolic rate. They should be able to observe a daily calorie consumption expectation based on their BMR. And finally, they should be able to observe a daily calorie consumption expectation based on target weight goal. Now, there are likely to be a few things in this list of requirements that are confusing. But I've broken the application down into smaller tasks, and I'm going to walk you through where I've got the information in order to tackle this problem. Now, an interesting fact about myself that not many people know is that I'm actually a qualified personal trainer. I'm very much into my fitness, and I love helping others achieve their goals. So this is something I use all the time in order to help customers work out whereabouts they should be sitting in terms of calorie consumption. Now, the first thing we're asked to do is create a function that can calculate a person's BMI, and the BMI formula is as follows. It's weight in kilograms divided by the height squared, where height is in meters. So if we pop across to the NHS website, you can see here that we're told that the body mass index is a measure that uses your height and weight to work out if your weight is healthy. And it's calculated by dividing an adult's weight in kilograms by their height in meters squared. The next thing we're asked to do is create a function that can output a person's BMI rating, and on the same NHS website, you can see that we have the BMI ranges. So if a BMI is below 18.5, the person would be classified as underweight. If they're between 18.5 and 24.9, they're considered healthy. Between 25 and 29.9, the person would be considered as overweight. And if you're above 30, you'd be considered in the obese range. So the app needs to be able to tell the user what rating they are classified as. We're then asked to create a function that can calculate a person's BMR, where BMR stands for basal metabolic rate. And in order to determine this, we're going to be using what is known as the Mifflin-Centaur equation. And I have picked this information up from the omnicalculator.com website, as you can see here. So what the BMR will actually provide is an estimate of the amount of calories that a person will burn whilst at rest. In other words, if you were not to do anything during the day, this is the amount of calories that your body will burn from all the chemical reactions that occur in everyone's body to maintain a living state. So with this information, based on our activity levels, we'll be able to estimate how many calories each of us consume on a daily basis. Now, the next function we're asked to create is using the Harris-Benedict equation, which is used to determine an individual's total daily energy expenditure. And the Harris-Benedict equation is a formula that uses the BMR, which is calculated in the prior function, and then applies an activity factor to determine the total daily energy expenditure. So if a person doesn't do any exercise, we need to multiply their BMR by 1.2 to give us an estimate of the amount of calories they'll burn in a day. If a user considers themselves as lightly active, in other words they do sports or exercise 1 to 3 days per week, we need to multiply their BMR by 1.375. If they're considered moderately active, i.e. exercise 3 to 5 days a week, we need to multiply their BMR by 1.55 to give us the calories that they would burn on a daily basis. Very active people will need to multiply by 1.725, and if someone is extra active, i.e. they have a physical job and they do very hard exercise 6 to 7 times a week, maybe twice a day, we need to multiply their BMR by 1.9. Now this will give us the amount of calories that a person will burn having considered their daily lives, i.e. their activity levels. And with this information, we can do one important thing. Depending on whether the user wants to lose weight, gain weight, or maintain weight, we have to either be below this number, above this number, or consume the same amount as this number in order to achieve the respective goal. Now the next thing we're asked to do is, depending on what the target weight that the user would like to achieve is, and the time frame they would like to achieve their goal in, we need to determine the amount of daily calories that they should consume. And this is very simple. People complicate the art of losing or gaining weight. Now, if a person wants to lose weight, they should be in and maintain what is known as a calorie deficit. And a calorie deficit can be achieved in one of two ways. They can either eat fewer calories than what they burn, and the above functions provide us with the amount of calories that an individual is expected to burn on a daily basis, so they'd need to consume less than this number. Or another way of looking at it is that a person should burn more calories than what they eat, i.e. they should increase their activity levels in order to burn more calories. Now on average, it takes about 3,500 calories worth of energy in order to burn 1 pound of fat. In other words, in order to lose 1 pound of fat, an individual would need to create a deficit of 3,500 calories. So let's break this down even further. If we want a client to lose 1 pound of fat in a week, they should be having a calorie deficit of around 500 calories a day. In other words, 3,500 divided by 7. And if we achieve this calorie deficit of 500, then the individual should be on a path to losing that 1 pound of fat in a week. Now we can take the same assumption the other way. If an individual wants to put on weight, then they should be in what is known as a calorie surplus, i.e. above the expected daily calories that they burn on a day in order to put weight on. So we'll need to think how we can construct this program in order to give the users this type of insight. The last two things we're asked to do is firstly create a function to see if the user wants to use the app again, and this is something that we're familiar with. And finally, we need to generate a body statistics report for individuals who use the app. So with all of the functions that we create above, we're going to need to construct a program that asks for input at specific times, calls functions at specific times, and then displays information on the screen to help users understand what they need to consume in order to achieve their target weight goal. So this application will not only test what you've learned in Python so far and reinforce that learning, but it's also going to provide a very useful application that you can use in your own time in order to help you achieve your body weight goals. Good luck in developing this program, and in the next video, I'll show you the way I went about creating this application step by step. In this fourth project, we're going to recreate the popular game Rock, Paper, Scissors. So you can see here that Games Limited want to add to their collection of online games. They would like you to produce a version of Rock, Paper, Scissors. Now hopefully you're all familiar with the game Rock, Paper, Scissors, and you can just get started with the project right now. You've learned all the skills you need in order to create a working game. But if you're not familiar with the game, let me just explain what the application should do. Firstly, we need to obtain a computer-generated selection. So the computer should either select rock, paper, or scissors. Secondly, we need to allow for a user of the game to also select rock, paper, or scissors. Once the computer and a user have selected either rock, paper, or scissors, we need to evaluate who wins each round. Now the rules are simple. If one person picks rock and the other person picks scissors, rock smashes scissors and therefore the person who picks rock will win that round. If one player picks paper and the other player picks rock, paper covers rock, and therefore the person who picked paper would win that round. And finally, if one player picks scissors and the other player picks paper, scissors cuts paper, and therefore the person who picked scissors would win that round. We also need the application to keep track of who's winning the game. Now, if this is enough information for you, dive straight into the project and give it a go. If it's not enough and you want a little bit more guidance, the application can be broken down into the following tasks. Firstly, we need to create a function that obtains the user's input. We then need to create a function that generates a randomly selected choice for the computer. After both selections have been made, we need to determine the winner for each round and keep track of the score. Now, once the round has been evaluated and we move on to the next round, we'd want to create a function that checks to see if a user wants to play the game again. They may not want to. And finally, like we've seen in all of our other projects, we need to produce a working application. So we need to produce a working game of rock, paper, scissors using a while loop and the functions that we create in the above tasks. Now you may be thinking, this seems like a simple project. And based on previous projects that you've done and learnt, I'm hoping this is something that you can do in its entirety with very little help. But the thing to remember here is that reinforced learning is key. You'll start to do things naturally without even thinking about it. Remember, there are so many different ways that you could achieve this program, but the goal here is to create a working game of rock, paper, scissors. Don't worry about how clean or efficient your code is for now, just utilize the features of Python to create something that works. With that being said, good luck in developing the Rock, Paper, Scissors game for Games Limited. Okay, so how did you get on in the Rock, Paper, Scissors project? Hopefully it went smoothly. If it didn't and you got stuck in any places, not to worry. Let's see if we can code it up together now and get a working solution. So the first thing we're going to do is import a useful function and a useful library that will help us in creating the game. So firstly, we're going to import the clear output function, which we know is from ipython.display, and this will just help us keep a clean program at the end when displaying the information to the user. So we can put from ipython.display import clear_output. Secondly, because we know we need the computer to generate a randomly selected item from either rock, paper, or scissors, we're going to import the random module. Okay, so with the imports now complete, let's dive straight into creating the game logic. Firstly, we're asked to create a function that obtains the user's input. So we know to create a function we need to put the keyword def, so we'll put def, and then we'll call this function get_user_selection, and then we'll put parentheses with a colon. Now the first thing I'm going to put within this function are the items that a user can select from. Now because we know they can only choose between rock, paper or scissors, we're going to set a variable called choices, and inside this variable we're going to store a tuple, i.e. an immutable object with the items rock, paper and scissors. I'm then going to set a variable called user_input and set this to an empty string. Now the reason I'm doing this is because I'm now going to create a while loop that just checks to see if the user input variable that we've set above is not in choices. So I'll put while user_input is not in choices, i.e. when it doesn't equal rock, paper or scissors, then we want to keep asking the user for input. So I'll then put user_input as the variable and set this equal to the input function that asks the user to enter a choice. We'll then put in brackets rock, paper, scissors, and then we'll put a colon. Now after this input function, you may have noticed that in choices I've started each item with a capital letter. Now, because we're comparing this user input to what is in choices, I'm therefore going to capitalize whatever the user puts in. Therefore, if they put the whole word in capital letters or the whole word in lowercase, it will convert it to a capitalized version of the word, and it should therefore equal choices. After this user underscore input definition, I'm going to put the keyword continue. Therefore, if a user was to put the word hello, we would then continue back up to the while loop. Now, user input now contains hello, it's still not in choices, and therefore we're going to get asked for user input again. If the user input is rock, we then go back up to the while loop. User input is now in choices, so the not in choices evaluates to false, and therefore we're going to then return the user underscore input, which in this example would have been rock. So we've now defined a function that can obtain a user's input. Okay, so moving on to the second task. We're asked to create a function that generates a randomly selected choice for the computer. So once again, we're going to start by defining a function. So we'll put def, and the name I'll provide this function is computer underscore generated underscore selection. I can then put parentheses and a colon. In a similar way to what I did in the first example, I'm first of all going to set a variable called choices, and then I'm going to create a list of items that the computer can select from, so we know this is going to be rock, paper, and scissors. And after this line, I'm going to create a variable called computer underscore selection, which will just store the computer selection, and I'm going to set this equal to a call from the random library, and I'm going to call upon the method known as choice. So I'm going to put random.choice, and inside the parentheses, I'm going to pass in what items we want the choice to be made from, and in this example, we know we want to pass in the variable choices. And if you needed help to understand what the choice method would do, as a reminder, you can press Shift and Tab, and it will provide you some documentation. So here you can see that the method choice is asking for one parameter called sequence, and it tells us that this method will choose a random element from a non-empty sequence. Well, we have a sequence defined above called choices, which is simply a list. We can see that it's non-empty because it's populated, and therefore we'll get a choice from one of these three items. The final thing we need to do is return the computer's selection, so we need to return the variable computer underscore selection. Okay, so that's the second task complete, but let's just test to see if the computer generated selection function is working as we expect. So let's call upon it to see what we get back. You can see that when I call upon computer generated selection and then press return, we get paper returned. And if I go back up and run the function again, we get scissors returned. If I run it again, we get scissors once again. A fourth time, we get paper. Let's run it until we get rock. There you go, on the next time we run it, we get rock. So you can see that the computer is generating a randomly selected item from the list of choices. Okay, so moving on to the third task. We're asked to determine a winner for each round and keep track of the score. So in order to do this, I'm going to create a function that deals with both the conditional statement, so to determine who the winner is, and also keeping track of the score. So firstly, I'm going to define a function called determine underscore winner. And inside this function, I'm going to want to pass in two parameters. So this function will always expect two pieces of information. Can you guess what this is? Well, my thinking is that because we need to compare the player choice and the computer choice together, I'm going to want to pass in these two bits of information into the function. So I'm going to create a parameter called player underscore choice, and I'm also going to create a parameter called computer underscore choice. These will be the only parameters that I include, and I'm going to therefore put a colon after this function header. Now we know we also need to keep track of the score, and we haven't seen this in an example yet, so I'm going to implement this in a slightly different way. My expectation is that when I get to the very last step and produce a working game, I'm going to create a variable called player underscore score, and I'm going to set that equal to 0 to begin with. I'm also going to create a variable called computer_score, which can store the amount of points the computer gets. But in order to access these two variables that I'm going to define outside of the function, and bearing in mind I want to change these variables, I'm going to precede these two variables with the keyword global. And we saw the keyword global when we discussed scope. So I'm going to put global and then player_score, and then I'm going to put global computer_score. Now, whenever I reference or change the values that are stored in these variables, it will change what is stored in the global variable. In other words, a variable that can be accessed anywhere in your code. Okay, so we can now move on to determining the winner of each round. And the way I'm going to do this is by simply putting in place some conditional statements that checks to see what's stored in player choice versus what's stored in computer choice, and then we will print a message to the screen that tells the user who won that round, and we also then need to change the value that's stored in either player_score or computer_score in order to update the scores accordingly. Now the first thing I'm going to do is firstly see if player_choice is equal to computer_choice. Now if player_choice is the same as computer_choice, we know that it's a draw. They've both selected the same item. So we can therefore print both players selected curly braces, we can then put a full stop, and then we can put it's a draw. We'll then use the format method and we can pass in either player_choice or computer_choice. So let's just pass in player_choice. Now this will actually cover 3 eventualities. For example, if player choice and computer choice both are rock, then it's a draw. If they're both scissors, then it's a draw. And if it's paper, then it's a draw. So there are 3 combinations here that will always result in a draw. So it's good to put this line of code first so you don't have to write them out individually later on. So with the event of a draw now covered, we can then put our second conditional statement. So we'll put elif player_choice is equal to rock. Now notice here that rock is with a capital R, and that's because we actually capitalized the word when we created the getUserSelection function. Now if the player_choice is equal to rock, well the computer choice could be one of 2. It can be either scissors or paper. We've already dealt with the situation where the computer choice would be rock in the statement above. So we need to have a nested if statement. So after rock we can put a colon, and then we can put if computer_choice is equal to scissors, and then we can put a colon. So at this point we know that computer choice would be scissors and player choice would be rock. Well, rock smashes scissors, and therefore the person who picked rock would win. So because the players picked rock, we can print rock smashes scissors, you win. And then after this print statement, we want to change the value that's stored in the variable called player_score, which we know we're going to define later. So we'll put player_score, and then we're going to plus equals 1. Now inside this nested if statement, we also need to put an else clause. And the else clause will capture the event where the computer_choice is equal to paper. So we can put else, then a colon, and we'll then put print paper covers rock, because the computer choice is paper and the player choice is rock, and then we have to put you lose, because the player would lose in this instance. And at this point, we'd want to update the computer score variable and increment it by 1. We've then finished this conditional statement, so we can go back out to the outer if statement and then cover the other possible scenarios. So we'll put elif player_choice is equal to paper, we'll then put a colon, we'll then create a nested if statement, and we'll put if computer_choice is equal to rock. In this event, paper covers rock, so we can print paper covers rock, you win. After this, because the player wins, we'll want to increase the player's score by 1, so we'll put player underscore score plus equals 1. Now if the computer choice was actually scissors, we can put else and then print scissors cuts paper, you lose. And then we need to increment what's stored in the computer underscore score variable by 1. And finally, the last possible outcome we could have is where player underscore choice is equal to scissors. Now if player choice is scissors, then we need a nested if statement to check what the computer's picked. So we can put if computer underscore choice equals paper, then we can print scissors cuts paper, you win, and then increment player score by 1. We can then put an else statement where it captures where computer choice is rock. We can then put rock smashes scissors, you lose. And then we can increment what's stored in the computer underscore score by 1. Now at this point, the function is complete. But we can't call upon this function yet because there are some variables inside this function that we haven't created. For example, player underscore score and computer underscore score. So we'll pause on this function for now and see if it's working when we get to the end. Okay, so moving on to the fourth task, we need to create a function that checks to see if the user wants to play the game again. And we've seen this before, so we can quickly go through this with hopefully very little issues. So we'll create a function called play underscore again, and then we're going to set a variable called replay and have this set equal to the function input with the message, would you like to play again? With some guidance that we want to either receive a Y or an N, so we'll put brackets Y/N and then a colon. We then need to check what they've put in, so we'll go if replay dot lower, so we'll convert whatever they put in to a lowercase letter, and then a set of parentheses is equal to the lowercase y, then we want to return true, because the user has stipulated that they do want to play again. If they haven't put a y, we'll then put else and we'll return false. Now this could be implemented better because if you think about the risks that could arise here, if a user put nothing or a z or an n or a p, whatever the value they put, it's going to return false. But for now, because we're just trying to get a game that works and we have provided them some guidance as to what we want to see, we'll just put else and then we'll return false. And this function should work accordingly. Okay, so we're now at the point where we need to create a working game using the functions that we've created above. So we just need to make sure that we're setting variables and calling the functions in the correct order in order to make this game function. Now you may recall that earlier I mentioned that when we created the determine underscore winner function that I wanted to set two variables in the global scope, outside of the function and also outside of the while loop. So that's the first thing I'm going to do. The two variables that I created were called player underscore score, so I'll put player underscore score and set this equal to a score of 0 to begin with. And I'll also do the same for the computer's score, so I'll put computer underscore score and set this to an initial value of 0. I will then create the while loop. So I'm going to put while true and then a colon. So if you think about this, the only way that we can break out of this loop, considering that true is always equal to true, is if we break out of the while loop with the break statement. So to start with, I just want to welcome the player to the game. So I'm going to print a message that says, welcome to the rock, paper, scissors, arena. I'm then going to, straight after this welcome message, print out the current score. So I'm going to print the current score is with a colon, and then on a new line I'm going to print player with curly braces. Then I'm going to put the pipe symbol. I'm then going to put another set of curly braces, and then I'm going to put computer. And this reads very similar to how it would if you were watching a sport event. I'm then going to use the format method, and inside the brackets, the first curly braces are going to contain what is stored in player underscore score variable. I can then put a comma, and the second set of braces are going to be inputted with what's stored in the computer underscore score variable. Okay, so at this point, we're just printing some statements to the screen. Now, inside of our determine underscore winner function, we've included two parameters. So we're expected to get a player choice and a computer choice. So the first thing I'm going to do is actually get a variable which stores a value for these selections. So I'll start by creating a variable called player underscore choice, and I'm going to set this equal to a call on the get user selection. So when the while loop gets down to this line of code, the user is going to be asked for their selection. And when they're put in a valid selection, it will get stored in a variable called player underscore choice. Great. So now let's do the same for the computer choice. I'm going to create a variable called computer underscore choice, and I'm going to set this equal to a call on the computer underscore generated underscore selection function. So this will therefore store a randomly selected item from rock, paper or scissors and store it inside the computer underscore choice variable. Now at this point, I've got two pieces of information, and I've got some print statements that are displaying some information to the screen. But I'm actually going to clear what's stored on the screen by using the clear underscore output function, which we know is Jupyter specific, just to keep it clean. And after it's been cleared, I want to print a statement to the screen, which tells the user what they've chosen versus what the computer chose. So I'm going to print you chose and then curly braces. I'll then put a comma. I'll then put computer chose and then curly braces. And then I can use the format method and place player underscore choice in the first set of braces, and then I'll put computer underscore choice in the second. Now at this point, all we've done is tell the user what they've selected and also what the computer has selected. But we haven't actually determined who has won the round. So we need to call upon our determine underscore winner function. And we know that this function takes in two arguments, one that relates to player choice and one that relates to computer underscore choice. Now we've called them the same thing here, so we can actually pass in our variables called player underscore choice as the first argument, and we'll pass in computer underscore choice as the second. This function will then be run, and we're going to compare the two values based on our conditional statements that we had written above. Now after it's determined the winner, we need to obviously display who has won and what the score is. So we can print to the screen the current score is, and then we can put the same line of code that we put above. Now theoretically we could have put this in a function so we're not repeating ourselves, but for the purposes of this example, let's just copy and paste the code again. Now the determine underscore winner function actually updates the score as well. So where we're calling and printing the player score and computer score for a second time in this while loop, we would have expected the winner's score to be updated by 1. And at this point, the round is over. We've already compared the values, we've already seen who's won, so we need to check to see if the user wants to play again. So what we can do is put if not play underscore again. And the only way that this will evaluate to true is if a user doesn't want to play again, because if they don't want to play again, we'll return false. The opposite of false is true, and therefore, when a user doesn't want to play again, we want to clear the output, so we'll call upon the clear underscore output function, and then we will print hope to see you soon. After this line, we're going to break out of the while loop because they don't want to play again. Now, if the user does want to play again, they'll put y. Y returns true in the play underscore again function. The opposite of true is false, and therefore the if statement's code block will not be executed, and therefore we don't break out of this loop. But what we do want to do after they've decided whether they want to play again is clear underscore output, because the first thing that's going to happen when we go back up to the top of the while loop is we print out welcome to the rock paper scissors arena, the current score is, and it will then display the current score after the first round has been played. Okay, so we're now at the point where we can test our game. Let's see if the game functions and operates as we would expect. And the way we're going to do this is by going up to kernel, and then we're going to click on restart and run all. This will run all the cells that we've written so far, and we'll see how the while loop then performs. Okay, so you can see that when we get down to the while loop, we're presented with the message, welcome to the rock, paper, scissors arena. The current score is 0-0. Enter a choice, rock, paper, or scissors. So let's play the computer at a game, and we'll say that the first person to 3 wins. So I'm going to start by entering rock. Yes, rock smashes scissors, you win. The current score is player 1, computer 0. So it's working as we expect. The player did win, and hence the player's score has incremented by 1, and we're then asked if we want to play again. Let's put a capital Y. Great, so welcome to the rock, paper, scissors arena. The current score is 1-0. Enter a choice. Okay, this time I'm going to go with paper. Ooh, the computer also selected paper. It's a draw. Would you like to play again? Yes. This time, let's go with scissors. Ah, rock smashes scissors. The computer chose rock, therefore the player loses. The current score is 1-1. Would you like to play again? Yes. This time I'm going to go rock. It seemed to be lucky the first time. Ooh, they also selected rock. Let's go rock again. Ah, the computer chose paper. We lose. The current score is player 1, computer 2. Would you like to play again? Yes. Let's go with scissors. Oh, the computer went paper. It's 2-2. First 1 to 3 wins. Would you like to play again? Yes. Let's go with paper. How lucky. Computer chose rock. Paper covers rock. You win. The current score is player 3, computer 2. Great stuff. Would you like to play again? Let's put N because we don't want to go any further. And then we're presented with the message, hope to see you soon. Great. So we've managed to create a very easy rock, paper, scissors game, which is actually quite engaging with very few functions and a very small while loop. But hopefully you're now starting to get to grips with how we can present information to the screen, how we can create functions and call upon them, how we can store information in variables, and all the other features that we've learned throughout the course so far. All of these mini projects are a great way to try to solidify the knowledge that you're picking up throughout the course. If there's any part of this project that you didn't understand, please make sure you get in touch because it's so important that you understand the language first and foremost. We will make sure we get your understanding back on track so that you're not lost in subsequent parts of the course. I hope you enjoyed that project. See you in the next one.